Hello and welcome to Physics Doctor. This is Dr. Ghanshyam Rejani and let's start. Class 11, chapter number 3, Motion in a Straight Line. In the similar chapter, it is covered in the JEE and NEET unit number 2, which is called Kinematics. And this is session number 8 of chapter number 3. What are we going to learn today? Graphs. Isn't it new for you? I don't think so. So, to be precise, we are going to learn one is position and time graph, velocity and time graph, acceleration time graph, and also how to read this graph. And we will be solving large number of examples, right? That examples are from NEET, JEE as well as from the books also. And today we are going to solve 44 examples. So be happy with this. Let's start. See what is graph? So it is just a graphical method for what? To study a motion of an object. What are we going to do? Motion of an object can be represented by a position time graph, velocity time graph, and acceleration time graph. Such graphs are powerful tool to present and analyze different aspects of motion of an object. If you see our previous session, we have been studying motion subjected to one dimension. In this graph also we will be targeting one dimensional motion. And there are two methods. One, by using mathematical equations. We have equation of motion for velocity. When velocity is constant, equation is delta s divided by delta t. We know that if acceleration is constant, we have equation. What is equation? V is equal to u plus at. Also, we have two more equations. V square is equal to u square plus what plus what? Tell me all the equations. Let's see. By using these equations also, we can solve. But there is one more method. There is a graphical method, and we can use this one. Let us understand the detailed explanation. First, let us start with various graphs with the use of a straight line. You know the straight line meaning is that it is giving a short test distance between 2 points. If I take point number A and point number B at here, if I join this with a short test distance, that become line that we know already. So we're starting with straight line. How it works? So it gives a linear relation between y and x, and that represents a straight line. We consider here this is x axis and that is y axis, and if you draw a line, that is a straight line, and we know that equation of a straight line. What is? Tell me. Yes, sir, it is y is equal to mx plus c. It is well-known equation and everyone know it very well. And you must have studied this equation many a time. Of course, I agree with you. Definitely, we know this equation in a detail, but let us understand with some more details. Because in the analysis of graph or preparation of graph, we need a thorough understanding of this equation. So here, in this y is equal to mx plus c, the term m, it represents a slope. It shows slope of line. Here, if you see drawing number 1 and drawing number 2, both are given. And this is a line we are talking about, that equation is equal to y is equal to mx plus c. And this m, it represents slope. Slope, that means this theta angle, and therefore it becomes m tan theta, m tan theta. So that is slope. We can also take the distances. Say for example, if we give name, this is a, B, C. And if you wanted to have solution tan theta, so we know that it is a perpendicular side divided by nearer side. That we can get. That we can get. That we know, right? So this is ultimately what it is, a slope. It is. And C, that is another constant. We know that C is a constant. C is a constant, but it is also known as intercept. It is also known as intercept, or to be precise, it is known as y-intercept. Not y, not why. It is not y. Here it is y. Intercept. See, when x is equal to 0, when x is equal to 0, that means that term is 0. Y becomes c. Y is equal to c. Y is equal to c, and it shows that graph passes through which line, graph passes through which point, that is c, that is c, it is showing like that. So here this is y intercept where line cuts the y axis. If c is positive, if c is positive, it cuts above this line. This is x and that is y, so above x line. And if c is negative, that means it should cut below xy line. That should cut below xy line. That you have to understand in a detail. So slope, we know that it is defined by tan angle of, right, tan angle made by the straight line with positive axis in the anti-clockwise direction. The line, if you want to represent this angle, it is with x-axis. It is with x-axis, and it should be in the direction of anti-clockwise, or we can say counterclockwise. So we have to move in this side, and this angle, this is the angle, this is the angle. We cannot take opposite side. You cannot take opposite side. This is wrong. This won't be similar here. If you see another line, there is another line, there is another line. So again, we need to take x-axis, and angle should go in the direction of counterclockwise or anti-clockwise. That becomes theta. So here there is a important conclusion, that is a theta for this line. If you see theta, it is less than 90 degree. When there is a theta is less than 90 degrees, so tan theta, we know that 0 to 90 degree, it give always positive value. So that become the slope. When theta is less than 90 degrees, slope is greater than 0, or simply we can say m is positive, or simply we can say slope is positive. And when this theta, if you see here in this second case, it is definitely greater than 90 degree. It is definitely greater than 90 degree. So in this case, tan theta become 90 degree. Tan theta become negative value. It become negative value. Therefore, this slope is less than 0, and that become negative. That become negative. So when there is a angle is less than theta, slope become positive, and when that angle is less than theta, slope become negative. It is simple conclusion that we have to know it very well. And here theta is always lies between 0 and 180 degree. It must be always in between 0 to 180 degree, right? So again, if this theta is less than 90 degree, if theta is less than 90 degree, it is slope is positive. If theta is greater than 90 degree, slope is negative. Slope is negative. This is very important part. That means slope, it is represented by m, and m is equal to tan theta. M is equal to tan theta. And another part, c. If c is positive, it cuts above xy line. If c is negative, it cuts below xy line of y axis. We will see more in detail also. Now, so we know that c is equal to y intercept if x is equal to 0, when there is a value of x is equal to 0. So at that time, this line cut y-axis. This line cuts y-axis. So it shows the point where line cuts y-axis. So in the figure number one, this is we are talking about this figure, right? Slope. We know about slope. When this is less than 90 degree, slope is positive, and when this intercept is above x, that means positive. That means it is also positive. Right. So here both are positive. C is also positive as well as M is also positive. Then next figure, figure number two, it is here. What about theta? Theta is greater than 90 degree. It is clearly visible. That means slope is negative. That means slope is negative. M is negative value. M is negative value. C, it cuts above, right? Y cuts above this x axis. That means it's a positive. C is positive. In the figure number 3, this is the figure number 3. See, we have to draw this line and that angle should be with x, and we have to go in the direction of counterclockwise. So, of course, this angle is less than 90 degree. This angle is less than 90 degree. Theta is less than 90 degree. So, slope is positive. Slope is positive. And C intercept, this is y intercept, it is below x line, so it become negative. C become negative. C become negative. So for the C, there are these options possible. Then if C is equal to 0, if C is equal to 0, that means what? Original equation is y is equal to mx plus c. That means y is equal to mx. Y is equal to mx. Y is equal to mx, right? So this has to pass through, the line has to pass through this origin, because it is c is equal to 0. C is equal to 0. So this line has to pass, it may be in this direction, whatever, positive. If it is positive, so it should like that. This is the theta, and it should passes through the origin if c is equal to 0. If c is equal to 0, we know it very well. See, these small concepts are very much important, because physics, when you're talking about JEE NEET, it deals on concepts and you have to understand all the concepts. Next is y is equal to c. Equation is what? Y is equal to mx plus c. Y is equal to mx plus c. That means this term it is omitted. Y is equal to c. That means x is equal to 0. For all values, y is constant. For all values, y is having just a constant one value. Whatever value we take for x. So this is here x value. X is 0. Y is c. X is 1. Y is c. X is minus 1. Y is c. That means it gives a straight line. And that line is also parallel to x axis. That line is parallel to x axis. So when x 0, or simply you can say y is becomes c, at that time line is always parallel to x axis. And similar, when x is c, equation, what is equation? Y is equal to mx plus c. If this term it is not there, it is not there, right? And here x is equal to c, x becomes c. M is also constant, so you can take an opposite side and direction can be flipped. So at that time, for any value of y, if y is equal to 0, x is c. Y is equal to 1, x is c. Y is equal to minus 1, x is c. It gives straight line, vertical line, and it is parallel to y axis. So this you have to understand when we are talking about different graphs. This is different properties of a straight line. So one example, let's take an example. Draw the graph for the equation 2y plus 4x plus 2 is equal to 0. So we know that equation of line is equal to y is equal to mx plus c. We have to convert this equation 2y plus 4y plus 2 is equal to 0 in this term. Can we convert this equation? Of course, we can. It is very simple. So y, just divide this by 2, this by 2, right? So it becomes like y is equal to something x, something c. So simplification is given here, y is equal to 2x minus 1. It is very simple, we know it very well. From that, can we identify values? M is minus 2, that means m is negative. M is negative, one thing. Second thing is that c is minus 1, that means c, the y point will cut at minus 1. That means y intercept, the line cuts one position, it is 0 comma minus 1. 0 comma minus 1, it cuts at this position. M is negative value, that means theta should be greater than 0. Theta should be not 0, theta should be greater than 90 degree. So this should be greater than 90 degrees. So line it is like that. And tan theta is equal to minus 2. Tan theta is equal to minus 2. That we know it. That we know it very well. So we already seen that c is equal to minus 1. So that line should cut at 0 comma minus 1. 0 comma minus 1. Then we can put values. We can put values here at y is equal to 0. At y is equal to 0, we can take y is equal to 0, and we may find value of x. Value of x. So x is equal to minus 0.5. We already have 1 point. Here y is equal to 0. So that next point becomes 0.5 minus 0.5 comma 0. So another point we can find. It is very simple to get it. So line passes through another point minus 0.5 comma 0. First represent x value, second represent value of y. So it is very simple. Let's have one more. Draw the graph or the equation 2y plus 3x plus 2. What is the equation of line? Y is equal to mx plus c. We need to convert this into that equation. That means you just divide this equation by 2. By 2. What become? This become 3 by 2x plus 1. 3 by 2x plus 1. What is 3 by 2? M C1. C1. From that C, directly we can identify. It is going to cut y-axis at position 1, 0 comma 1, 0 comma 1. And M is positive. That means angle theta should be less than 90 degree. Theta should be less than 90 degree. So tan theta is equal to 3 by 2. Tan theta is equal to 3 by 2. We can put y intercept. We already have. So line passes through 0 comma 1, that we all know very well. What next? We can find next point, or we can take slope. We can take slope. So this side should have 3 and nearer side should have 2. Is it correct? Is it correct? Is it correct? Think and tell me. Think and tell me. So how another point we can find, x is equal to c minus c by m, where we take y is equal to 0, y is equal to 0. Put this value, y is equal to 0. So we can find x is equal to minus 2 by 3. X is equal to minus 2 by 3. So here that point is minus 2 by 3 comma 0, and you can draw a line. So representation of line is very simple. Let's initiate position time graph by taking very simple example. So example is given like that. Consider the simple case in which an object is stationary. See, in the case of position time graph, we can take one that is vertical line, and second that can have horizontal line, and at one side we can show time. This is axis representing time, and another side can represent its position. We can say x as a position. So what is given? Consider the simple case in which object is stationary. So say for example, time is equal to 0, time is equal to 0, x is stationary, x is having stationary at some distance. Say for example, x is staying somewhere here at some distance, it is at stationary. X is equal to 1, for example. At time is equal to 1 second. 1 second, what is meaning? It is stationary, it should be stationary. So it should be like that. This point should be here. At 2 second, it is again stationary. So it should be here. At 10 second also, it is stationary. So if we draw its line, what become? We will be having this kind of graph, a straight line graph, right? A straight line graph. When we talk about a simply object which is a stationary, that means it is not having any movement, any motion. Such graph is always like that, a constant. Very simple, isn't it? Second case, if an object moving along the straight lines covers equal distance in equal interval of time, in equal interval of time, it is said to be uniform motion along the straight line. We know that if distance traveled by an object which is equal, so let's do a graph. One side is showing t, another side is showing distance or position of x. Fine. So it start maybe zero, at time zero. Say for example, if it is located here at 1 second, it is traveling 1 unit. So we can take combine, and that is somewhere here position. Fine. At 2 second, it travels 2 unit. If you combine this two, somewhere here position, and maybe it may be 5 second. At 5 second, it travels five. It travels five, something like that, and it is here. If you draw, if you just plot, if you plot this lines, or if you join this line, so it is going to be a straight line. It is going to be a straight line, but not horizontal, and it is having equal distance on the both the side. It is having equal distance on the both the side. So here we already gone. This is case number A, where it gives a straight line, horizontal line with T, because here X is not moving at all. X is stationary at some particular place. You may imagine like that you start from your home, and maybe 9 at morning 9 if you are at your college, or maybe at your school, right? And your vehicle is outside, right? Your vehicle is outside, your vehicle outside. From 9 to maybe 5 if your school time, that means you are located at the same place. Your vehicle is also located at the same place. So for that, if I do displacement diagram of your position, it is going to be a straight line which is parallel to T. In the second case, say for example, you are driving your vehicle at 1 meter per second. Means if 1 second is passes, you travel 1 meter. 2 second passes, you travel 2 second. 3 second passes, like that. So it gives us a inclined line, but it is again a straight line. It is inclined line, but it is a straight line, and this gives us uniform motion. This gives us uniform motion along the straight line. Very simple. So this is just a simple position time graph representation. How it works. So first is for stationary object which is not moving, and second is an object which is moving with uniform motion. With uniform motion. Let's have one more example, which is a realistic example. Example number 3 is given, like consider the motion of a car. Say for example, you start your car. So that start from the rest. So we know that when we start a car, it starts from zero. It starts from its zero movement, zero motion, and then there is an increase of speed of a car. Increase of speed of a car. So here it is given when time t is equal to zero. It starts from the origin. So starts from the origin and pick up speed till 10 seconds. So what we do? We initially accelerate our car, and then initially there is some increase in speed. Increase in speed. Maybe say for example here it is around 70 or 80 kilometer per hour. Let us just assume. Then what we do? We run a vehicle at some constant speed. So there is a straight line. That straight line shows constant speed. If there is an increase, so it shows increase of velocity, or simply we can say increase of acceleration. There is a positive acceleration for that. So thereafter moves with uniform speed. So this region it gives uniform speed, velocity is constant here, velocity increases. Then the brakes are applied and the car stops. So brake is applied somewhere and there car stops. Whatever position it is there, it maintain at that position. At maintain. You can take example. Say for example, you start from your home. You may after 2 3 seconds, you increase your velocity or speed. So at 8, it may be 8 seconds or somewhere here nearby, or it is mentioned here 10 seconds. So let's take 10 seconds. At 10 seconds, you might have reached around 70 kilometer per hour. What do? You just go on with some constant speed up to some point. Then suddenly, if there is some animals, right, or some person, right, they come in between vehicles. So what we do? We suddenly apply brake, and there is a speed reduction. There is a speed reduction, right? So here, this is the graph for the displacement or maybe a distance travel. So you might have traveled 300 meter, and this position can be there. So this is very simple graph to be plot. You may try after this tutorial also. Let's move. Another is average velocity and average speed. What is the difference between average velocity and average speed? We know it that very well. When an object is in motion, its position changes with time, but how fast is the position changing with time and in what direction? So that define average velocity. When we talk about direction, that defines velocity. So we know that average velocity is equal to v delta x by delta t, x2 minus x1 divided by t2 minus t1. That we know very well. Say for example, in the graph we can see here there is some object start with 0 and that keep on accelerating. Therefore, it is having curvature. That is having curvature and it is accelerating. Then object means traveling along x direction and with respect to t. How this is accelerating, we can see here. If you just see this 5 meter distance travel in a 4 second. But if you see from 4 to 5, that means it is taking 1 second. 1 second it is traveling another 5 meter. Right. So first 5 meter it is taking 4 seconds, but for the next 5 meter it is taking only 1 second. So that's we know that from that velocity is increasing. When we talk about average velocity, so from P1 to P2, we take direction, and from that value, we just find out value of x2, that is 1727.4 minus x1, that become minus 10. And what about time? What about time? It is taking 5 to 7, it is taking 2 seconds. So it is average velocity is 8.7 meter per second. 8.7 meter per second. But when we talk about speed, we cannot take x2 minus x1 as a straight line. We have to consider length of this curvature. So that gives us speed. So remember that part. When there is a talking about velocity, of course, it is a shortest distance you need to take. You need to take shortest distance. But when there is a word about speed, you have to take this curvature. You have to consider this curvature. Otherwise, your answer is definitely going to be wrong for that time. So we know that average speed versus average velocity. We know it very well. Average speed is equal to distance divided by take total time. And when we talk about velocity, so it is displacement divided by time. We have our full session on speed and velocity, distance and displacement. I think you should study from that session so you will have better understanding. So we understand that when there is the increase of x, if increase of x, that means x2 is greater than x1, velocity increase. Velocity is positive. Velocity is positive. If here this is x1, this is x2. If x1 is greater than x2, that means velocity is negative. And here last case, if you see the last case, right, see here there is no change in terms of displacement or distance. That means here there is no velocity or path at rest, or velocity is equal to zero. There is no velocity. It is not moving. Component is not moving. Object is not moving. Let's take an example. Example number 4. A car is moving along a straight line, says OP. So it is given here. This is car is moving from O to P. This distance it is traveling in the figure. So now it moves from OP. It moves from O to P in 18 seconds and returns from P to Q, and it returns from P to Q in 6 seconds. In 6 seconds. What are the average velocity and average speed of a car? First position is going A from O to P, and B is given from O to P and back to Q, from back to Q. See, we have a full session on displacement and distance, velocity and speed. I think if you do not know what is meaning of velocity and what is meaning of speed, I think you should take that session in advance. So let's start with this our understanding part. So how it works? So velocity, we know that velocity is a vector quantity, directional property, so is equal to delta x by x delta t. So that is become x2 minus x1, t2 minus t1. That is here delta x. It is displacement. When we talk about average speed, it is total distance travel. Total distance travel, right? Direction doesn't matter. Direction doesn't matter. Divided by the same time, similar time. So when we talk about first case, it is asked the average velocity and average speed of car from O. Object starts from O for the first case and it moves to P. So what it travel? It travels 360. So we know that V bar is equal to delta x, 360 travels, and it is taking 18-second time for the first interval. So 360 by 18, that become 20 meter per second. And what about average speed? Total distance is 360 and total time is 18 seconds. That is, the both the answers are correct. So see, average velocity and average speed can be equal. Average velocity and average speed can be equal. In the second case, it is mentioned that the object moves from O to P. That means it is traveling 360 in 18 seconds, and it is returning to 240, means Q. That means this distance has to be reduced when we talk about velocity. So in case of average velocity, distance is travel. It is a shortest distance we have to take. So it is 240. So it is 240 divided by total time 18.6. That is 10 meter per second. But when we talk about average speed, so we have to take total distance. So here 360 plus this 120 divided by total time. Time is similar. 18 plus 6 is 20 meter per second. Is 20 meter per second. So velocity, it is 10 meter per second because here we need to consider direction. But when we talk about speed, so it takes total distance. It is taking total distance, right? So here it is 20 meter per second. 20 meter per second. So what say this shows that speed in general greater than magnitude of velocity. Speed, right? We can write greater or equal to. On based on that, you may find several questions also. You may find various questions based on this. So average velocity you can take less or equal to average speed. You can write in the opposite part also. Now we understand what is velocity. Now let us understand acceleration. So the velocity of an object in general change during course of motion. It is just showing a course of okay, this change of motion with time. We know that very well. So see, should it be described as a rate of change of velocity? So see, before the acceleration was defined at that time, people were confused. What should be acceleration? What should be relation for that? Should I be velocity with distance? Means velocity divided by distance, it should be acceleration, or velocity divided by time, it should be acceleration. There was a confusion among scientists, among researchers, and this was also a problem. It was faced by Galileo. Yes, sir, Galileo's time. This the problem was there. How to define this acceleration? There was no logic for that. So firstly, it was defined as it is a rate of change of velocity with displacement. Initially, definition was given. Acceleration word was not utilized at the time, but see there was some change in the velocity. It was seen and how to define for the further activities. So it was initially defined like that change of velocity with distance. See, we don't have any term as of now. Even today also we don't have velocity divided by distance. Do we have velocity by distance is equal to any term? If you have, please comment me. We don't have any. So what happened? See, then Sir Galileo. Yes, sir, we have to take sir. Sir Galileo studied motion of a free falling object. So object when it is free fall, he identified that change of velocity with respect to time, it is constant. When object is having free fall, so that Galileo identified that velocity, change of velocity with respect to time, it is a constant, right? And velocity with distance. Say, for example, an apple is falling from the tree. So it is having some velocity v1 here, it is having velocity v2 here, and traveling distance, say for example h1, right? And it is taking some time t1. So here v1 by t1 we can consider, and we can consider v1 by h1. Again, it is moving in the direction. It is having v3, taking some time. Say for example t2, it is traveling distance h2. So if we take, or you can say v1 minus v2, right? v2 minus v1, right? And here you can take v3 minus v2 divided by t2 taken, and v3 minus v2 divided by time taken, not time but h2. So in the case here, Galileo identified that this ratio of v to t remain constant. Ratio of velocity to time remain constant. That in this case, acceleration was defined, and average, not it is not velocity but it is acceleration. Average acceleration is equal to delta v by v is become v2 minus v1 divided by t2 minus t1, and we not to worry about now about this term. Do you know this answer? What is change of speed with time? What is change of speed with time? See, average acceleration is not a change of speed. It is a change of velocity. It is a change of velocity. See, but as we have only acceleration. Do we have any other term like we have for the speed and velocity? But do we have any other term in the case of acceleration? Actually, we don't have any term for this. And alternately, acceleration is used for the change of velocities as well as speed also. But you can be the next Galileo or next Newton by answering this question. You may give name for this average, or you can say change of speed with time. You please comment me your answer in the comment section. So now acceleration that was defined like that in the history. How to plot acceleration graph? See, we already studied various equations for the acceleration in terms of constant acceleration and motion graph. Here the acceleration is non-uniform and linear over the period of 0 to 10 seconds. Say for example, the data is given like that acceleration. It is non-uniform, and it is linear. It is linear from 0 to 10 seconds. So it is just either it is increasing or decreasing. Acceleration is positive. So it is increasing with a straight line up to 10 seconds. That means velocity is also increasing. Simply, logic is very simple. It is object, it is increase with velocity. Fine. So from 0 to 10 seconds, there is some acceleration. There is increase of acceleration we can identify here. Then acceleration becomes 0. Acceleration becomes 0. So it is on the 0. Acceleration from 0 to 18 seconds. So here acceleration is 0. And here acceleration is having some value. We don't know. We will learn this part. So acceleration is 0 from 10 to 18. Then there is a from 18 second to 20 second. There is a constant deceleration, we can say, or retardation. If there is a minus signature, minus sign, so there is a minus 12, and it is a constant. It is a constant retardation from 18 to 20. It is minus 12. See this in this case we can draw or we can plot acceleration versus time graph like that. We will take more example. Don't worry at all. This is just I am showing sample for the acceleration. So here there are two conditions we can see. When acceleration is equal to 0, line it passes through x or x axis or timeline. Here it is 0. When there is a linear increase, so it is showing a slope, positive slope. It can be a negative slope also. And when there is a negative, so here it shows directly a straight line. When there is a constant part, negative position and constant, so it is showing a straight line. Very easy to understand, I think. So next, let us understand position time graph, and this detail will start from this point. So we know that velocity is equal to delta x by delta t is equal to x2 minus x1 divided by t2 minus t1, and that gives us slope. That gives us a slope is equal to tan theta. So this is, let us consider line number 1, and it is having slope. It is having slope theta. Is it positive or negative? If theta is less than 90 degree, this is slope is positive. If you take, this is drawing number 2, theta is greater than 90 degree, so this slope is negative. So what are we going to check while reading the graph or while preparing the graph? So first case, we need to check whether angle is 90 degree, less than 90 degree, or greater than 90 degree. So we know that if it is less than 90 degree, slope is positive, and if it is greater than 90 degree, slope is negative. So first consideration, we have to check this theta. If it is less than 90 degree, slope is positive, and if theta is greater than 90 degree, slope is negative. We need to draw slope with the x-axis. With the x-axis, you can draw x-axis here also. This is theta. We may draw here. This is theta. The next condition, if theta is equal to 0, that means this line is parallel to t. This line is parallel to c. So theta is equal to 0. Here we are talking about graph x versus time, distance, or you can say displacement versus time. Distance or displacement versus time. If it is having zero slope, or you can say theta is equal to zero, object is stationary, object is raised, or simply you can say velocity is zero. Velocity is zero, or you can say object is raised. One more option is possible if theta is equal to 90 degree. If theta is equal to 90 degree means vertical line. If this line is vertical, if this line is vertical, if this line is vertical. See, that means it shows very high velocity. Practically, this is impossible case. Practically impossible case. But in examples, you may find this kind of graph, vertical lines. It shows infinite velocity. It shows infinite velocity. But practically, it won't happen. There is always a gradual increase in velocity. So you need to check first angle. If it is theta is less than 90 degree or theta is greater than 90 degree in the most of the cases. In very few cases, you may see theta is 90 degree or theta is equal to 90. It is majorly not available. So first checkpoint is you need to find slope. If it is positive, then velocity is positive. Slope is positive, velocity is positive. Slope is negative, velocity is negative. Then second is if slope is constant, velocity is constant. If you see here, if you measure slope of this line, one number, slope of this line, theta, if you measure here theta, if you measure at any position that becomes theta. For the second case also, if I measure this at any position, this become theta. If I just extend this line, this become theta. All thetas are equal. All thetas are equal. So for the straight lines, when there is a straight line at angle, right? What it shows that velocity is constant. Velocity is constant, and if velocity is constant, acceleration is zero. If velocity is constant, acceleration is zero. So this is checkpoint number two. This is checkpoint number two. Checkpoint number three. If line is not a straight line, if line is not a straight line, if line is not a straight line, so you need to check whether slope increases or decreases. Say for example, there is some curvature. In this drawing, there is some curvature. If there is some curvature, let's take what it tangent. You know that slope is, say for example, if we take point from this position, so slope is tangent, which we can draw. We can take one more point here. We can draw slope. It is here, and let's change the color. So the first point we know that theta 1 and this second point theta 2. Can we say theta 1 is less than theta 2? Yes, of course. So what we can say here, we can conclude here, slope increases. Slope increases. Theta 1 is less than theta 2. Slope increases. Again. Let's see again. You know the tangent, if I draw tangent, so it is a tangent gives slope of that instant, say for example point A. And if I draw tangent with some different color, let's take this red color, and let's have blue as angle. So this is theta A, this is theta B. Can I say theta A is less than theta B? That means slope increases continuously. If slope increases, meaning is that velocity increases. If slope increases, velocity increases, See, if you see here with this time, say for example 10 second, distance travel, maybe 10, take further 10 second, distance travel looks like more than 30. For the similar 10 second it is, so what we know velocity is equal to 30 by 10 is equal to 3 something. In the previous case it was 10 by 10 is equal to 1. So 3 is bigger value than 1. 3 is bigger value than 1. That means what? Velocity increases. See, velocity increases. In the other word, we can say acceleration is positive. Acceleration is positive. Acceleration. See, velocity increases means what? If acceleration is positive, then only velocity increases. If there is some acceleration, then only speed increases or velocity increases. Therefore, acceleration is positive. Acceleration is supporting increase of velocity. So you have to understand this part. Similar opposite is also true. If slope decreases, if slope decreases, if slope decreases, if slope decreases, velocity decreases and there is a negative acceleration. Acceleration should be negative. If there is a retardation, then only velocity decreases. We understand that. We understand very well. So this two you have to remember. Then what next? Then we can compare here. Right. So before that, let's also take one more example. If I want to have tangent, so I can take Tichuk. This is and another tangent here. This is Tichuk, 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 Tichuk. Let's take. So let's take this is point number A and this is theta A and this is point number B and I can take parallel line. This is theta B. Can I say theta A is greater than theta B? That means angle decreases, angle decreases, angle decreases. We can have this case. We can have this case, right? And in third case, if you see here, this is let's just take this position. Let's take one Tichuk here, second Tichuk here. So what is the case? This is theta 1, this is theta 2. Theta 1 is smaller than theta 2. So angle increases, velocity increases, velocity increases. And for this half, another half, let's take here one Tichuk and another Tichuk here. So this become theta A, this become theta B. Can I say theta A is greater than theta B? That means angle is decreases, angle decreases, velocity decreases, negative acceleration. And the last checkpoint, when there are comparison between two lines, so if we just compare theta 1 and theta 2, just see this drawing, top right hand top cover. So shallow slope, we can say this is theta A and the steep slope that is theta B. That is theta B. That is theta B. See, we know that theta B is greater than theta A. That means theta B slope represent higher velocity. If the steep slope, it represent higher velocity. A bigger slope, it is having a bigger velocity. It is having bigger velocity. So this four you need to remember. You need to remember that part. And there is also shortcut. There is also shortcut for that. For that, for the acceleration time graph, there is also shortcut. You can identify whether acceleration is positive or negative. Now, if you see this, is it visible to you? Yes, it is visible. You can see here. This is a shape. We can see here. We can see here. This is a shape. This is a shape. This is a shape. We can see here. What is the name of this shape? This is known as concave. This is known as concave shape. Concave shape. This is a concave shape, like a vessel. Vessel. Most of the vessels are having this kind of shape. Katora. It is having this kind of shape. So this shape is known as concave shape. If we take if we move from this point, first position theta 1. This is tangent. It is showing the first position theta 1, theta 2. Here it is theta 2, like that, theta 3, theta 4, theta 5, theta 4, theta 5. If you see here slope, so first M1 is having the biggest, largest slope. We know that this is the theta 1. This is the for the first one. This line is having theta 1. It is the biggest one. It is the largest one. If we take here theta 2, it is slightly smaller. So here M1 is less than M2, less than M3, less than M4, less than M5. So you can see there is a slope in this case continuously increases. Is it like that? slope is continuously increasing, that means acceleration is positive. There is an increase of acceleration. So whenever you see there is a concave shape, always consider acceleration as a positive value. Always consider acceleration as a positive value. And if this is shape, this is convex. This is convex. Another shape, it is convex. This shape is a convex shape, and when there is a convex shape, acceleration is always negative. Acceleration is always negative. So slope m1 is having the biggest, then slope decreases, slope decreases, slope decreases. You may try also. You may try by yourself also. So this is a shortcut when there is a concave shape of graph, positive acceleration. Or it is also vice versa. If acceleration is positive, graph is always concave, and if acceleration is negative, graph is concave. Which graph? Position time. We are talking about position time, right? We are talking about position time graph. Now, in the case of velocity time graph, what we are going to learn here. So, if velocity and acceleration both are having similar size, that means both are positive or both are negative. If both are having positive, that means velocity increases. See, if velocity direction it is positive and acceleration is also having positive direction, that means both are supporting each other. So there is the increase of velocity. There is the increase of velocity. If velocity is negative direction, acceleration is also negative direction. That means both are supporting in the negative direction, accelerating v velocity in the negative direction. That means there is an increase of velocity in the negative direction. So that is the case. Second is if velocity and acceleration both are having opposite sign. In this case, velocity decreases. Velocity decreases. If acceleration is negative, in this case also velocity decreases. If velocity is negative, in this case, velocity decreases. Let's see. So what are the four options are possible? One is velocity. Say for example, if we draw a graph, like that, this is graph y, displacement versus time graph. If you draw a graph, right? So here, with the increase of velocity, velocity is increases. So what happen? Both are having velocity as well as acceleration. Both are increases. Therefore, velocity is also. If you just draw a graph for the velocity, so velocity is also increases. If velocity is positive, but acceleration is negative. Negative acceleration means there is a reduction. It is taking velocity reduced side. So that means velocity decreases. We do graph for that. So velocity decreases. Similar case, when there is a negative velocity, if you draw graph velocity versus time, if there is a negative velocity and acceleration is positive, right? If there is a velocity is negative, so it what happened? It decreases, but in the negative direction. See, line goes in the upper side. But here it is minus v, minus one, minus 2, minus 3, right? So in this case, if it is minus 3, because of this negative acceleration, it become after some time it become minus 1. So it is decreasing. In the direction you have to understand that part. And in the last part, if velocity is negative, say for example, negative 1, and there is a negative acceleration, that means it is again decreasing. But see, if we see it is minus 2, minus 3, so actually it is increasing in the negative direction. So you have to understand this concept very well. So now we have better understanding of position time graph. One graph is shown here as a sample position time graph of two different objects. Say for example, x object number b, it starts from distance, say for example 10, and object number B, it is starting from 20, and both are moving in a straight line. Both are moving in a straight line. So what we can call for this two lines? See, if we take angle this theta of A and theta of B, so in this case we can say theta A is equal to theta B, and this angle represent velocity. So that means both the parallel lines always shows equal velocity. So this is very simple concept that need to understand. There is a one more for that. See, you can see there is a another drawing. We will understand in more detail with a different example with more understanding. So let's see first it is A. This is line number A is given. This is line number B is given. So if we just take theta, this is theta A and this is theta B. So can I say theta A is greater than theta B? That means what? Velocity of A is greater than velocity of B. We are not discussing about other components as of now. We just talk about velocities, right? So both are having unequal velocities, and velocity A is greater than velocity B. Let's have one more. Let's have one more. So A position is given. A position is given. If we take this, so this gives us theta A, and here this becomes theta B. See, theta A is less than 90 degree. Theta B is greater than 90 degree. That means what? That means what? A is having positive velocity and B is having negative velocity. A is having positive velocity, B is having negative velocity. In addition to that, suppose if I draw horizontal line and if this is theta A and if I draw another one theta B, if both are equal, that means both are having equal and opposite direction. Both are having equal and opposite direction. So let us read different graphs. Which graphs? Position time graphs. So first, if you see the first graph, A is having one axis, it is x, it is showing position, and the opposite side it is showing time. So graph, it is having slope is 0. So see, we already have conclusion when there is a slope is 0, that means velocity is 0. Velocity is 0 and object is stationary. Object is stationary. That we know it very well. So slope is 0, velocity is 0, acceleration is 0. It is not required even to check. So body at rest. Body at rest. First example is very simple. Now we need to check example number 2. B, it is given here B. So there is an inclined line. It is x and t is shown. What is first check? We should check first angle theta. Is it less than 90 degree? Yes, it is less than 90 degree. That means here in this case slope is positive. Slope is positive. Slope is positive. M is positive. Ultimately we can write velocity is also positive. So from that first we identified velocity is positive. There is a velocity and there is a positive velocity. What about acceleration? What about acceleration? So see here, velocity is constant because slope is constant. Slope is not changing. If you see angle of the slope, so that angle is theta 1, that angle is theta 2. We know that theta 1 is equal to theta 2. Slope is constant. That means acceleration is 0. Acceleration is 0. Right. So see, we already concluded that part. Here theta is less than 90 degree, that we already check here. Theta is 90 degree less than. So slope is positive, velocity is positive. Second, slope is constant, theta 1. you measure here or anywhere, it is having equal. That means acceleration is zero. Acceleration is zero. So first two examples are very simple to identify. Third, if you see here, there is some curvature is showing x and t diagram or graph. It is showing some kind of curvature. So what is our first check? First check, we can check angle. So let's take tangent here, somewhere tangent, and this is theta. Is it less than 90 degree? Is it less than 90 degree? Yes, theta is less than 90 degree. Ultimate, it gives velocity as positive. Velocity is positive. And what is our second check? What is our second check? You can take theta 1 and theta 2 as a comparison, and you can say that theta 1 is less than theta 2. But our conclusion, what is our conclusion? What is our conclusion? Or direct shortcut. See this shape, see this shape, see this shape. Can we say it is a concave? Can we say this shape is concave? Yes, if there is a concave, that means acceleration is negative. Acceleration is negative and it graph start from zero. Fine. So let us again bodies, not the previous one here. Theta is less than 90 degree, that already checked. So slope is positive, right? This theta tangent, we can take tangent theta less than 90 degrees, so slope is positive. Then what is next? The shape of this curve. What is this? This entire curve is concave. For the concave, acceleration is positive. Acceleration is positive. That means velocity increases. Velocity increases. So velocity is positive. Acceleration is positive. Ultimately, what it gives? It gives increase of velocity. Increase of velocity. So that is our conclusion. Object starts from the rest or origin with positive acceleration and positive velocity. And velocity increases with time. Velocity increases with time. Let's have D. Let's have D. So what is our first check? So our first check is to check slope. Let's have this point. Let's have this point. Tangent. I want to do a tangent. Can I say theta is less than 90 degree? Yes, that means velocity is positive. Wow. Velocity is positive. Velocity is positive. So theta is less than 90 degrees. Slope is positive. Velocity is positive. Velocity is positive. Good. Then what is second check? Second check is that shape. Is it convex? Yes, it is convex. If shape is convex, what should be acceleration? Acceleration should be negative. Acceleration should be negative. Shape is convex, negative. So here we have velocity as a positive, acceleration is negative. So ultimately what it become? Velocity is positive. Say for example, in the graph of v and t, velocity may be starting from here positive, but see acceleration is negative. Acceleration is negative. That means velocity decreases. Velocity decreases with time. Velocity decreases with time because of acceleration, negative acceleration. So what is our conclusion? So object starts from the rest, or you can say origin, from this point, and then negative acceleration with positive velocity. Velocity decreases with time. Velocity decreases with time. Very simple understanding. And the last one. Can you solve this and comment me? Or you should pause the video from here and can you comment from the graph number E? Let us just break this graph from here, right? So part number one, this part, if we take tangent, so this is less than 90 degree. Is it less than 90 degree? Theta less than 90 degree. Yes. Let us take from this position. Can I take this? Theta is Less than 90 degree. Yes. So see, for all the cases, theta is less than 90 degree. That means velocity is positive. That means velocity is positive. That we identified. Good. Second check, cup. Just check cup. First, this is the first portion. For the first portion, what is the shape? It is concave. When there is a concave, acceleration is positive. So for the first portion, it is concave. And what about second portion? What about second portion? It is convex. So it is negative acceleration, right? So first there is a positive acceleration, then there is a negative acceleration. Wow, wow, wow. So for the first half, positive acceleration, second half, negative acceleration. So for the first half, velocity increases, and for the second half, velocity decreases. Right? For the first half, velocity increases, second half, velocity decreases. So conclusion is starts from the origin from the zero, body accelerates first, accelerates, then deaccelerates. Body accelerates from deaccelerates. Isn't it simple? Yeah, it is very. We will be solving so many examples, so I don't think you will be having any confusion after studying this session. So let's go. Oh, few more examples. Few more examples. Wow. So we can see, let's have this is one, this is two, this is three. So let us checking first. So what is our first check? First check is theta. First we will be checking theta. So let's take tangent. Let's take tangent here. And what about this angle? Less than 90 degrees. So what is our conclusion? It is positive. It is positive. It is positive. Wow, great. Then what is second check? Second check is shape. 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 It is concave. That means acceleration is positive. Acceleration is positive. So acceleration is positive. Velocity is positive. Both are positive. So velocity increases. Velocity increases. Velocity increases. Right. So in the case of, let's call this f. So in this case, velocity increases and velocity starts from x0, or object starts from x0. It is not starting from the rest, but it is starting from the x0 at t0 time. So that is the case. So body starts from positive x0 with positive velocity and with the positive acceleration, and velocity increases. That is our conclusion. Good. So we have seen f. This is our f. This is f. What is next letter? G. G, sir. G. Good. So first check it is slope. This theta, can I say this theta greater than 90 degree? Yes, that means slope is negative, velocity is also negative. Good. Then this straight line, velocity constant, acceleration 0. Velocity constant, acceleration 0, and velocity it is decreasing. Velocity is decreasing with time. So velocity is constant, right? And it is not decreasing. It is velocity is constant, but it is negative velocity, only negative velocity. How can you confuse me? Don't confuse me. So solution is body starts from x0 and have constant velocity and negative velocity. Negative velocity. Good. Oh, this is another case. Body starts from x0. Body starts from x0. Then let's do from here, tangent, tangent. Let's go for the tangent, tangent, tangent. What about angle? What about angle? Theta is greater than 90 degree. That means velocity negative. So first check is theta greater than 90, velocity negative, and the shape. Next is shape. Next is shape. Oh, convex. Convex means acceleration negative. Velocity negative, acceleration negative. Velocity increases in negative direction. Velocity increases in the negative direction. Velocity increases in the negative direction, in this direction. Or you can say simply, we can say velocity decreases. Velocity decreases. Right. So see here, it is going towards negative side. If you extend this and go in the uh, you can say downward direction, downward direction, downward direction, right? So this is h. This is h. Body starts from positive and then negative acceleration, negative right direction, and velocity increases in negative direction, right? So see here, if you plot graph v versus t, so here graph starts from negative, graph starts from negative, right? Velocity, negative velocity, and it goes like that. So it increases in the negative direction because if it is taking -1, so it is -3. So -3 velocity is greater than -1 velocity. Don't confuse with math. The next is position time diagram, and you have very difficult, wow, difficult part. So we have to divide this into up to O to T1 portion, up to O to T1 portion. Let us take angle theta. Theta is less than 90 degrees. So velocity is position. For the first half, velocity is position. Wow, velocity is positive. Velocity is positive. Velocity is positive. And what about shape? Shape is concave. Shape is concave. The meaning is acceleration is negative. And for the second half, tangent. Let's do tangent, tangent, tangent. This is theta greater than 90 degrees. So here it is having negative velocity. In this side is having positive velocity. Wow, great. And in all the case, entire case, acceleration is negative because shape is convex. Yeah, this is not concave, it is convex. How can you make such mistake? Don't make. So it is having negative acceleration. So for the first half, velocity is positive, acceleration is negative. So what happened? Velocity decreases. Velocity decreases. So if we draw a velocity versus time graph, so velocity start from the positive, then it decreases, then it decreases, then it decreases. Right. For the second half, negative velocity, negative acceleration, negative velocity, negative. So velocity start from negative v and then it increases. Increases means what? -1 like -3. So it going like that. It increases in this direction, increases in this direction, right? Don't confuse with direction negative, positive, otherwise you will have wrong answer. So body starts from the origin and then velocity of body decreases, velocity of body decreases, velocity of body decreases and becomes zero when there is a no slope. So here there is a no slope, no slope. No, it is slope, but slope is zero. Slope is zero, slope is no slope. So at that time at t1, it is momentary, velocity is zero, and then it decreases, it decreases, it decreases. Reverse direction increases. See, if you just consider a ball is thrown vertically in the upper direction. So what happens? It is having maximum velocity. Then velocity decreases when ball reaches to top position. Velocity is equal to zero. Then it goes downward direction. So downward direction velocity is negative. Negative velocity decreases, velocity will increases, and here when it strike on the ground, negative velocity is maximum. And here acceleration is equal to minus g. It is the similar example. It is the same example I am talking about. Isn't it nice? Of course, nice. Oh, one more opposite graph. Opposite graph. So let's divide. This is segment number one. This is segment number two. What is our first task? First task is to check angle. Yeah, great. Great answer. So this is angle. Let's check angle. You have to go with T line, horizontal line, and this is the angle theta. 1. Can I say 1 greater than 90 degree? Yes. That means for this portion, velocity is negative. Velocity is negative for this portion. Yes. And for this second, let's do tangent. Let's do tangent. Let's do tangent. This is theta 2. Can I say less than 90 degree? Yes. So velocity is positive for this action. Good. What about shape? What about shape? Shape is convex. That means acceleration is positive. Now we have everything. Great. For the first half, theta is greater than 90. So negative velocity. For the second half, theta is less than 90 degrees. So it is positive velocity. Great. And what about acceleration? Acceleration is always positive. It is always positive. Wow. So for the first half, velocity negative, acceleration positive. So what happened? Negative velocity decreases. If I draw a graph, this is velocity and it is t. So it is having negative velocity somewhere here. Negative velocity, and there is a acceleration. So negative velocity decreases. So decreases negative velocity in this direction. Right? Don't confuse with the direction, otherwise you will have a big problem. And then second half, velocity positive, acceleration positive. What happened? This is v versus t graph. Velocity is positive, so it is above line, and it increases. It increases because acceleration increases. So it is like that. Great. I think you have understood that part. This example is ex- exactly mirror of the last example. So body starts from origin. Yes. Then velocity of body decreasing till t1. There is a decrease of velocity. Then here 0. So here it is maximum velocity. Decreases velocity. Here it is 0. Then increases, and here it is maximum velocity. You don't get confused with positive negative side, otherwise you will have huge problem. You repeat, right? You repeat the session again and again, then only you will be able to understand. And acceleration is always positive. It is like a reverse gravity kind of phenomena. It is taken here. Oh, one more example. One more example. Wow. So what is our first check? First check is take angle, tangent. Can I say theta is greater than 90 degree? Yes, sir. That means velocity is negative. Slope is negative, velocity negative. Second, shape is convex. Means acceleration negative. Both are negative, so velocity increases in negative direction. Here it is t, v, velocity negative v increases in the negative direction. Good. So body starts from the origin. Velocity of body increases in negative direction with negative velocity. Great. With negative direction also. Oh, hey, something new is visible here. Now we are talking about velocity time graph. And so many examples are here. But not now. We are not solving now. Let us understand rules. First, rules are similar to the displacement time graph. So we know that velocity time graph of uniform accelerated motion, equation of acceleration is change of velocity divided by change of time, v2 minus v1 divided by t2 minus t2. So it also shows slope. So in the case of when there is a graph, velocity to time graph, this slope, or whatever slope it is there, this slope now gives us acceleration. See, in the previous case, when there was a position time or displacement time, it was velocity, but here the graph is velocity time, and therefore acceleration it is given by m and theta. Great. So rules are same, checkpoints are same. First is if theta is less than 90 degree. This is theta less than 90 degree. Theta less than 90 degree. So acceleration is positive. there is a positive acceleration if theta is this case. If you take this case, theta is greater than 90 degrees, so slope is negative, acceleration is negative. Acceleration is negative. Acceleration is negative. If slope is 0, if slope is 0, if slope is 0, that means velocity is constant. Velocity is constant. Acceleration 0. And if slope is vertical, see it is just an imaginary condition. Acceleration is very high, or you can say velocity is very high, but this case does not exist. But you may see some example on that. Imaginary examples, they may ask. So this is first checkpoint. You just need to take theta. Second is that if slope is constant, if slope is constant, if slope is constant. So that means acceleration is constant. If slope is constant, that means acceleration is constant. If slope is constant, acceleration is constant. If slope increases, acceleration increases. If slope decreases, acceleration decreases. We can identify with the use of similar concave and convex shapes. Majorly it is not required. And then comparison of theta, if theta 1 is theta 1, say for example, let's draw another line. And this is theta 1, this is theta 2. If theta 2 is greater than theta 1, then it is having higher velocity, it is having higher acceleration. Great. So see, rules are very similar. There isn't any change. Only at place of velocity now we are writing acceleration. Rules are same. And there is one more acceleration slope VT graph displacement under the area. See, if we just draw area, if we take this area, if this area, it gives displacement. Here, whenever you see this kind of graph, you just do V divided by T is equal to area under velocity line. Velocity is meter per second, time is per second. This is become mega, right? So whenever you see area, you just multiply V with T, and this below area, it gives displacement. It gives displacement or position. Very simple logic. So one more thing you need to remember here. This not you need to remember, but it is I think understood by everyone. So let's solve. Let's solve. Oh, first A. Let's solve first A. See what is slope? Slope is 0. Slope is 0 means velocity constant, acceleration 0. So first case, if you see the first case, slope is 0, acceleration is equal to 0, velocity constant. Very well understood. Very well understood. Great. B. This is B. Slope theta is less than 90 degree. That means acceleration is positive. Velocity increases linearly. Slope is constant. Acceleration is constant. So body start from the rest and have constant acceleration. Velocity increases at constant rate of acceleration. Great. Then third case, if you see this B and C, very similar. Theta is less than 90 degrees. That means acceleration is positive, and velocity, right? Acceleration, velocity is having slope is constant. That means acceleration is also constant. Velocity increases with time. But see here, there is a difference here. Velocity start with some positive velocity. We can say V0 fine. So theta is 90 degrees, slope is positive, acceleration positive and constant, and right velocity increases fine. Body starts from U and with positive acceleration, constant acceleration, and velocity increases. Shall we go to D? Oh, there is some sign change. There is some sign change. Velocity starts with minus u. Negative velocity starts. If you take angle, this theta is less than 90 degree. Theta is less than 90 degree. That means acceleration is positive. Acceleration is positive. Acceleration is positive. So here theta is less than 90 degree. Slope is positive. Acceleration is positive as well as the line is straight line. That means acceleration is also constant. So for the first, if we take this half, this portion, so u is negative, right? U is negative. So velocity is negative, acceleration is positive, right? So here it decreases in negative direction, so it go upward, it goes upward. So it can be seen, it can be seen from that. And then after velocity become positive, acceleration is also positive, so it is going up, it is going up, it is going up like that. So V onwards, velocity is positive, acceleration is positive, velocity increases the direction. So what is our conclusion? Start with negative velocity and velocity increases with acceleration constant. So acceleration increases, fine. So velocity is also increases. See, acceleration is not increases, acceleration is constant, or acceleration is positive. Therefore, velocity increases. Next, E. E is here. You just need to extend this line. So theta is greater than 90 degree. So acceleration is negative. Acceleration is negative. Acceleration is negative. Theta is greater than 0. 90 degree acceleration is negative starting from the position O. Starting from the position O. V negative, A negative. So it is increasing in the negative direction. Velocity increases in the negative direction. So it starts from the rest, or you can say origin, and then velocity increases in the negative direction. You can see also, it is also visible from that. What about F? What about F? See, initially velocity is positive. Start with positive velocity. Then what about slope? What about slope? Slope of theta is greater than 90 degrees. So acceleration is negative. Acceleration is negative. So theta is greater than 90, slope is negative, acceleration is negative. So velocity starts from positive and it decreases, it becomes zero momentary, then it goes in the opposite direction, direction changes, and then it increases in the negative direction. Good. So V is 0 onwards, negative acceleration, negative velocity, both are negative, so increases in the negative direction. Great. And the last one, it is G. Starts with negative velocity. Great. What about angle? Angle is greater than 90. So acceleration is also negative. Both are negative, both are negative, both are negative, both are negative, both are negative. Means what? If both are negative, it increases in the negative direction. Velocity increases in the negative direction. Wow. Good question we have. So what is next? So next we have few more questions. Very simple. First question, it is with the velocity and time graph. Velocity and the time graph. Velocity and the time graph. So what here? See, velocity is 0, slope is 0, and velocity is constant, but see it passes through t. So velocity is 0. V is 0. V is 0. V is 0. Final velocity, initial velocity, everything is 0. Body is always rest. And there is, see, if there is arrow, if it is showing arrow, if you see in the previous cases, there was just a line, right? So see, if there is a line is ends here, that means our experiment ends. This is final time. But if there is a arrow, that means body continues in the direction for an infinite time. See, you have to understand there is a difference between if there is an arrow, if there is no arrow, right? So here body is always rest in a continual motion. Second is slope is zero. Slope is zero. Yes, slope is zero. Velocity is constant, and v is equal to v zero. Velocity is constant is equal to v zero. Velocity is constant is equal to v zero. Great. So body is moving with constant velocity v zero. Yes. So next what? Theta is less than 90 degree. Theta is less than 90 degree. Acceleration is positive. So velocity increases. It start from zero. It start from zero, and velocity increases at a constant rate. Great. I think you understood. You understand it better than me. Oh, few more examples. Few more examples. So first one is that it is starting from v0, and this theta is greater than 90 degree. Wrong. It is less than 90 degrees. So acceleration is positive. So body start with initial velocity v0, and velocity, positive velocity increases at constant rate. Second case, if we take theta is greater than 90 degree. That means acceleration is negative. Acceleration is negative. So from 0 to t1, what happened? Velocity v positive, acceleration negative. So there is a reduction. Velocity reduces up to t and then becomes 0. Here it becomes 0. Here it becomes 0. Then here velocity is negative. Acceleration is also negative. So it increases in the negative direction. It increases in the negative direction. You cannot write here, or you can say write as other direction, but here it is. It should be increases in negative direction. It increases in the negative direction. Wow. So here from onwards, a negative, it B increases in the negative direction. Oh, last one starts from zero. Velocity starts from zero. Let's take tangent. So this angle is less than 90 degree. Acceleration is positive. Acceleration is positive. Starts from initial velocity v0. V is positive. V is positive. V is positive. Why it is decreases? Why it is decreases? Why it is decreases? This is wrong. So T0, the body comes from the rest instantaneously and reverse its direction from the motion, then continues to move with the increasing direction. So let's have this drawing. So where it starts from zero, fine. Then we can have a slope. Tangent. Theta is less than 90 degrees. So velocity is positive. Is it velocity positive? No, acceleration is positive. Velocity is itself positive. So both are positive. Velocity is less than 90 degree. Acceleration is positive. Velocity itself positive. So velocity increases. Velocity increases. Velocity increases. Velocity increases with time. Right. Body starts from the rest. U is equal to zero. Velocity increases with positive acceleration, and acceleration is also increases. Maybe, may or not be. Fine. Oh, another graph. You can see here. It is starting from 0, v0, velocity starts from v0. Let's take tangent. So this becomes theta greater than 90 degrees. So acceleration is negative. Theta is greater than 90 degree. Slope is negative. Acceleration is negative. So what happened? From 0 to t0, velocity is positive, acceleration is negative, and it decreases, reaches to 0, and further it increases in the opposite direction. So from right 0 onwards, you can see 0 onwards, or you can say t0 onwards. From t0 onwards, velocity negative, acceleration negative, and therefore increases in the negative direction. Wow, I think you must have understood that part. Body starts with initial velocity v0 at t is equal to t0. The body comes to rest instantaneously and reverse its direction of motion, then continue to move with increasing speed in negative direction. Here we arrived at third quadrant. There is no fourth quadrant, so don't worry. So acceleration versus time graph, and it is very simple. It is a good news for you. Here, acceleration versus time graph. If you see the first graph, it is showing acceleration on the y-axis, and the time it is showing on the x-axis. If there is a straight line, what is the meaning of straight line? Acceleration is constant, and if it is above t, that means acceleration is positive. See, we don't have any term rate of change of acceleration. We don't have any term like that above that. So acceleration is the end point. So the second, if this is A and T diagram and this is acceleration part. So here it is negative acceleration. Here it is negative acceleration below T line. So it is negative acceleration. Here it is positive acceleration. And third gram, if it makes some angle theta is less than 90 degree, it is increasing linearly with time. It is increasing linearly with the time, right? So first slope, for the first case, slope is 0, A is constant. Body moving with the constant acceleration. Second case, slope is 0, acceleration is constant, and acceleration of body is negative. So body is moving with negative acceleration. This is the second case. This is first case. Third case, A start from the 0 and then positive velocity, right? Acceleration is proportional to time, that we know that, and acceleration is increasing with time linearly. Acceleration is increasing linearly with time. Very simple. Let's have similar case. First case, slope is 0 or it passes through t, that means acceleration is 0. Acceleration is 0. Body is moving with constant velocity. If acceleration is 0, velocity is constant. For the second case, slope is 0, acceleration is constant. So acceleration of body is constant and velocity and positive. Therefore, velocity increases with acceleration, positive acceleration, which is constant, right? Acceleration is constant. Here, if it is below, means negative acceleration, right? Slope is 0, A is constant, but negative acceleration, slope is 0, but showing negative acceleration, that means velocity decreases with negative acceleration. Very simple, very simple. Complexity decrease. Wow. Few more example. So what is this? Similar case, you may have seen theta slope is 90 degree, that means positive acceleration is positive, and acceleration increases, start from 0, it increases linearly. Great. Second is A start 0, this angle is theta is greater than 90 degree, that means slope is negative, acceleration is directly proportional to negative t, and it is decreasing. So minus acceleration is increasing linearly in negative direction. Acceleration is increasing in negative direction. Great. And the last is slope is positive. If we draw the slope, this angle theta is less than 90 degree. Slope is positive. That means it's a positive. Acceleration also, acceleration increases. Acceleration is not constant, but acceleration increases. Right. Start from 0. Acceleration increases non-linearly. Non-linearly. Wow. Whatever visible directly you can write for this case. Acceleration time. And this is the example is given when graph for free fall, the object which falls freely from the top. So we know that it is having acceleration is equal to negative g. Object is when it is moving freely, so it is subjected to negative g. It is subjected to negative g. So here it is, a is negative g, acceleration versus t gram negative g, and a is constant. So first graph is easy to understand. It is very easy to understand, right? It is very easy to understand. Now, here, when we talk about velocity, so objects start with zero velocity and it is going the downward direction, so it should have negative velocity. Downward velocity we consider as a negative velocity. We have to consider as a negative. So we know that negative velocity and negative acceleration, gives us negative velocity increase in negative direction. So therefore, it starts from zero. That start from zero. Velocity increases in the negative direction. Velocity increases in a negative direction. Wow, wow, wow. Let's again repeat. So from AT graph, first acceleration is negative minus g, so constant. So it is very simple. Here it is a is always constant. For the VT graph, negative minus a is constant. Minus a is constant. So velocity decreases, right? Velocity decreases linearly. Velocity decreases linearly because it gives negative acceleration. Negative acceleration. This should decrease. Or in the other word, we can say velocity increases in the opposite direction. You can change velocity increases in the negative direction. We can say in the xt graph. See here, acceleration is negative. Acceleration is negative. Acceleration is negative. That means what? The graph should be like that, convex. Graph should be like convex. So now the question is that should we start from this point in the mid position or last position? Let's say one, two, three, one, two, three, one, two, three. And for that, what we should check? We just need to check angle. We just need to check angle. We just need to check angle. Theta is greater than 90 degree. Greater than 90 degree. That means velocity is negative. So for the convex also, that theta should be greater than 90 degrees. So for that, if we draw tangent for this side, so this become theta is less than 90 degree. So it won't work. If you draw theta from the opposite side, angle from the opposite side, so it is theta is greater than 90 degree. So yes, it works. It works. So this side graph is correct. This side graph is correct. So here we start from this position and draw this shape convex. Oh, very simple. Don't go for equations and this all time. Right? It is very difficult to understand and remember each of the equation. It is difficult. So this is very simple method. You should go for that only. This method only. So let's solve. Let us solve example. A car starting from rest accelerates uniformly at 2 meter per second square. So here acceleration is given 2 meter per second square and it is starting. So initial position you can say u is 0 or x is equal to 0. Fine. X is equal to 0. For 5 seconds, you can say t1 is equal to 5 seconds. So a1 is 2 meter per second. Then moves with constant speed. Here velocity is constant, therefore acceleration is 0 for the next 5 seconds and then come to the rest. Retardation is given. So a3 is equal to minus 2 meter per second. Draw position time graph, velocity time graph, and acceleration time graph. Good. See, when these graphs are asked, I simply suggest that start with start with acceleration graph. Start with acceleration graph. So first is that acceleration is positive is given for the first a1 for the past one part 1 we can say a1. Acceleration is positive and constant. Acceleration is positive and constant. So see, velocity is also positive. So that means what? Velocity increases. Velocity increases. Velocity increases. Then acceleration is zero for the second case. Second part, acceleration is zero. Velocity is constant. And the third part, velocity decreases. Sorry, acceleration decreases. Acceleration decreases, and velocity linearly decreases. Fine. So what it means that if you draw acceleration versus time, right? So for the first 5 seconds, for the 5 second, and then we can have next 5 second, and then after, right? So for the first 5 second, acceleration is given 2 meter per second. So from there, if you draw a graph, so for the first 5 second, it is having acceleration is equal to 2 meter per second square. Then it is velocity is uniform constant, so it is zero. So it should be like that. Passes directly through directly. So here acceleration is equal to zero. Then acceleration become negative. So here negative minus 2 meter per second square, and then continue. Fine. So here this is the case. Now if we want to draw, then next from this graph, from the first graph, we can draw acceleration graph. Acceleration is already there. We should draw velocity versus time graph. So in the case of, let's draw here velocity versus time at 5 and at 5 plus 5, 10. You can write here at 5 plus 5, which is 10. So here, first case for the first part, velocity is a positive, yes. Acceleration is positive, and it is starting from zero. It is starting from zero. So velocity start from zero. Velocity is positive, acceleration is positive up to this point. So here it gives linear straight line. Velocity is positive, acceleration is constant. So therefore our line is a straight line. Our line is a straight line. You can reverse also, you may check. You may check reverse also. You may check in the reverse direction also. Then from that acceleration is zero, velocity should be constant. So you can go velocity constant, and then acceleration is negative, velocity is positive. That means there is a decrease. There is a decrease in the velocity. So velocity is positive, acceleration is positive for the first case, right? Slope should be positive. Slope should be positive. This theta should be positive. Second part, velocity is positive, constant, so x is linearly increasing. Then velocity is negative, concave shape. Fine. So let's erase this and again understand. So see here in the first graph, acceleration versus t. For the first part, acceleration is equal to 2. So acceleration is 2. Then it become acceleration becomes 0. Constant speed, acceleration becomes 0. And then acceleration become minus 2, negative. Right. Now, from this diagram, for the first part, here acceleration is positive, and velocity is also positive. So when velocity and acceleration both are positive, we know that velocity increases in a straight line. And here acceleration is constant, therefore this VT graph is straight line. So what happened? Velocity is starting from 0 and reaches to, how to identify 10 meter per second. So area below A line, area is equal to 2 multiplied by 5, it gives 10 meter per second, and that gives velocity. Here velocity is equal to A cross T from this graph, you can just find 2 multiplied by 5, so it gives velocity. So it is 10 meter per second, therefore it is 10 meter per second. Then velocity is constant, then acceleration is constant, therefore velocity is constant. So from point 5 to 10, 5 to 10 velocity, it is constant. So constant velocity. Then here, if you go here, so velocity is positive and acceleration is negative. Velocity is positive, acceleration is negative. That means velocity decreases. Velocity decreases. Here it is decreased velocity. We are calculating decreased velocity going in the downward direction. So this is the graph, right? So this is, we start from acceleration graph, acceleration t graph. And next we should draw velocity t graph, and then next is position. Next is position. So in the position graph, first we will see this slope. Is it positive? Theta is less than 90 degree. Yes, so positive. So in the case of displacement, or you can say position time graph, in the case of position time graph, right? Slope for the first portion, should be slope of the first portion should be positive, or you can say less than 90 degree. Second is that see here, for the first portion acceleration is positive. So we know that if there is a acceleration is positive, our shape should be convex or concave. Shape should be this. Shape should be this. And theta should be less than 90 degree. Where it happen? If we take this angle, this is this angle, then only it is 90 degree. That means this portion is required. So start from zero, it moves. Starting from zero, it moves like that, and up to s. How to find s? Yeah, area. 1 by 2, 10 multiplied by 5, because it is triangle, so 1 by 2 by 10. So it is 25, 25, 25, 25, 25, 25, 25. Then what next? See, slope is constant, velocity is constant. So for ST line should be straight line. ST line should have a straight line. Again, you can find this area, same area. How can you find area? We can find area by using this. This is 10 multiplied by 5. So 50, 50, 50 plus. We need to add the previous also. We need to add previous. So 25 plus 50, it gives us 75. Right. So 25 plus 75, 25 plus 75. So this is just an area for this section. But whatever distance traveled previously, that we need to add. So 25. And here velocity is constant. So slope is straight. Then for the last portion here, velocity is positive, but acceleration is negative. So for the negative acceleration, we have shape convex, convex, and convex. And if velocity is positive, theta should be less than 90 degree. So which side is required? See this side. If you do this, theta is less than 90 degree. Therefore this graph is required. So this graph, isn't it very simple? It is actually right. And similar here, if you wanted to have area, 75 plus this is area, 1 by 2, height 10, and that may be 5 multiplied by 5. right? So you can again 25, 75 plus 100, you can get your answer. So let's start example number 6. If acceleration of a body is 0, here it is given acceleration is equal to 0. Great. Then if the velocity of the body is v0 and it start from origin, that means u is equal to 0. Then if t is equal to 0, x is equal to x0. So there are different conditions are given. Let's go for the first condition. Acceleration is equal to 0. So we know that acceleration versus time graph, if you draw, this is time axis, this is acceleration axis. And if acceleration is equal to 0, so what are we going to get here? This acceleration graph, it is like that. This is the acceleration graph versus time. So if acceleration is equal to 0, that means if you draw velocity versus time, right? So here it should be a constant. There is no increase of velocity, there is no decrease of velocity if acceleration is 0. So graph should be like that. Graph should be like the straight line, right? Then if you draw graph distance versus time, distance versus time. So here, if velocity is constant, distance versus time, it should be inclined line. That we know it very well. Right? So here it is given acceleration is equal to 0. So velocity constant, st graph should be linear. That we already drawn. So here this is our st gram and this is v and v0. That is that given velocity. It is given v0. So we can draw like that. Then in the second case, so first case is done. This is case number 1. In the second case, if t is equal to 0, and x is equal to x0. So in the x0, in the first case, x was started with 0 position, origin position, and it is mentioned here start from the origin. But in the second case, it is mentioned that x start from positive x0. Otherwise, all other things are similar. Graph is at inclined line. V0 will start from the same position, but this graph changes and starts from x0. So this is number 2. This is number 2. In the same case, in the same acceleration 0, at t is equal to 0, if x is negative x0. So what should be answer? Yes, you are correct. This graph should start from negative x0. Graph should start from negative x0. All other conditions are similar. There is no change in the other condition. So it should start from negative. Right? So draw VT and ST graph. So these are the VT and ST graph. Here in all the graphs, first this common thing is that acceleration is equal to 0. Velocity is constant, right? And x is proportional to t. X is proportional to t. Example number 7, a body has constant acceleration. So it is mentioned here. Let's first draw acceleration versus time. So body has constant acceleration. This is the acceleration. It is constant. One condition is given u0, x0 and a0 are positive. Means x0 is positive, u0 is positive, a0 is positive. Right? All are positive. And we need to draw position graph as well as velocity graph. So if see there is a you can see here uh, acceleration is positive. Acceleration is positive. So what should be graph for the v and t. See, if this is a straight line, that means velocity and t graph should have inclined line. Velocity and t graph should have inclined line. That is for sure. So this is velocity. This is acceleration, and it's starting with u0. And all are positive. All are positive. So positive side. Fine. Then third graph, if you go with s t graph, so we have to just check. We have to just check here. Acceleration is positive. Hence it gives which shape? It gives which shape? Acceleration is positive, it gives concave. So this is the shape, this is the shape, this is shape. But we need to again identify. So angle, it is theta is less than 90 degree. So similar, the graph should be positive. Graph should be positive. If you draw tangent on this side, this is theta less than 90 degree. So this graph should work. This graph should work. So our answer should be like that. Starting from this, velocity, acceleration is positive, velocity is also positive. So velocity increases in positive direction. So here this should be the graph. Let's see here. Initial positions are positive u0, positive a0, positive x0. Fine. A is positive constant, so v is linearly increasing, that we already did in this graph. A plus, so it gives concave shape, and theta is less than 90 degree. Theta is less than 90 degree. We have checked. So solution is here a0, it is here, then slope a0, then see it is given u0, so you just need to shift this body at some distance u0. So this is our correct answer for that. So velocity is, this one is the correct drawing. Then what is mentioned here for that? The graph, it is concave, graph is concave, and this angle should be less than 90, means positive, and this graph starts from x0, so it should be at some upper side. The similar graph is just moved, right? So our answer is 1, this is, we can say 3 and 5 are our solution. 5 are our solution. So for the first case, it is done. u0 is initial velocity. So u0 is initial velocity. So this is for the second one. Then v velocity at any instant time. So for all the graphs, it will work. And x position for x0. So this is for the IB. Right. This is for the IB. We have here example number 8. It is somewhat similar to the example number 7. You may pause the video here and you may try by yourself. That's all. If a body has constant acceleration, so acceleration is constant, u0 and x0 are positive. So initial velocity, u0 initial velocity and initial distance x0 both are positive, and a is negative. A is negative. Acceleration is negative and constant. Fine. So it is given here. It is given here. Let's solve this problem. So when we talk about initial position, initial velocity is positive, initial acceleration is negative, and the distance, initial distance is positive. Fine. So what, starting with VT graph, let's start with graph. First, acceleration versus time graph. First, we are drawing acceleration versus time graph. So what is given here? Here it is given acceleration is negative and constant. So for the constant is straight line and acceleration is negative. acceleration is negative. Now next is if we draw second, if we draw velocity versus time, velocity versus time. So see, acceleration is constant, acceleration is constant, and initial velocity is positive. Initial velocity is positive. So what it gives? If any one sign is negative, that means velocity linearly decreases. Velocity linearly decreases. So initially velocity v0 is given here positive. Say for example, it is v0, and then linearly decreasing. So you can see here this kind of slope for the VT graph. For the VT graph, it crosses like 0 and then it goes in opposite side. It is fine. The next is when we talk about ST graph. ST graph, let's do here ST graph. It should be a straight line. Here ST graph. So we may divide this portion up to this. So first segment it is this one, and let's give this name as a T0 or whatever T1 fine. So negative, negative. First we identify shape. So a negative it is given, negative is given. So our shape of the ST graph it is convex. What is convex shape? This you can say inverse bowl is a convex shape. The next is initial velocity for this segment, segment number one. Segment number one, it is positive. It is positive. Segment number one, theta is positive because of what? Because of this velocity is positive. Velocity is positive for this region. For this region, velocity is positive. Therefore, here it is positive slope. So for this concave shape, it is not concave, it is convex. Convex shape, we need to identify theta is less than 0. So we know that it is very simple. From this, if I draw a line, so this theta is less than 90 degree. That means this side, left hand side will work. Left hand side should work. Left hand side should work. And another part is given. Another part is given here. It is positive. It is positive. It is starting from x0. Starting from x0, it goes up. It goes up, right? And then it should move in the downward direction. It should move in the downward direction. It goes like that. It goes like that. We identified shapes. We identified shapes for that. So t0 direction of the velocity, the direction changes from the displacement. See here, there is a velocity become negative. Here in this case, velocity become negative. So from this negative direction, the remaining slope, it is theta greater than 90 degree. Theta greater than 90 degree. So it works like that. Let's see the drawings. So here AT graph, here it is minus acceleration A0. Then in VT graph, if A is constant, this line should be slope. This line should be slope. A is negative, V is positive, right? So V decreases. Like that, it goes up to T0. Then in next case, what we need to check? In the next case, we need to check. See, in the case if x is equal to 0, then this will be drawing. Here it is x0. So in the next case, what is given? So we need to check first acceleration. Acceleration, it is negative. That means shape is concave, not concave, convex. This is the shape. This is the shape. And second is we need to check initially here u is negative and acceleration. Sorry, u is negative. That means slope is negative. Therefore, theta should be greater than. It is not negative. U is positive. U is positive. For the first case, u is positive, so slope theta should be less than 90 degree. So here this theta is less than 90 degree. At t0 it reaches to maximum point, and then here u become minus u, negative, and therefore slope theta should be greater than 90 degree. Slope should be greater than 90 degree, and here this is the case. See here, this slope is theta is greater than 90 degree. So this is the solution. Maybe little bit difficult at initial phase, but once you start understanding, that it won't be difficult for you. Let's have one more example of similar kind. If a body has a constant acceleration is constant, initial u0 is negative, then x0 is positive, and then acceleration is also positive, a0. Fine. So now let's again draw here our lovely acceleration versus time graph, and acceleration is given positive. Can we draw positive acceleration? So this is our positive acceleration is constant. Second is that v velocity versus time graph. If this is the constant velocity graph should have inclined line. Right? If it is first is straight line, second line should be inclined line in the VT graph. So here u is negative. So here somewhere below this line, here somewhere, say for example, this is negative u0, right? Negative u0. So we have here negative u0, and positive acceleration. So we know that because of this too, what happened? Negative velocity decreases, that means it goes upward. See, whenever you see positive a, line is going upward, and whenever you see negative a, line is going towards downside. If you remember this two, it will work always. So here it again crosses the direction, fine. Then when we talk about third graph, s versus t. So here at initially u is negative, or not u, just x 0 is positive, so it is starting from this point. Now what we need to check? We need to check first acceleration is positive, so shape is concave, and second is here u is negative, so slope should be negative, theta should be greater than 90. Let's check theta. For this case, if I draw this is less than 90, it won't work. In the opposite side, if you go, theta is greater than 90. So this side curve should work. So curve should be like that, starting from somewhere in this case, and then may go like that. Let's see how it works. So AT graph u0 is negative. This is given for ST graph. We already checked. A is positive shape, negative velocity. That already checked, right? So I'm not repeating this all. So here acceleration, it is given positive, so it is on the positive side. Acceleration is positive. Then negative acceleration, it goes like that. If it is straight line, that should be a inclined line. Negative u and positive acceleration, that means u decreases, right, in the opposite direction. So it goes on the opposite direction. Then next, if you want to just identify shape, A is positive, so it is con concave, and just we need to just move this direction on the initial u is negative, that means it should be theta is must be greater than 90 degree, and therefore this is the x0 starting with this. So this is the graph. Right. See, this is some extra bifurcation is also given if you want. At t is equal to t0, at t is equal to t0, at this position, talking about this position, right, x increases in the negative direction and t is equal to t0 onwards, x increases in the positive direction. You can have extra material for your understanding only. Let's have one more example of similar kind. I think this time you should pause the video and you should solve by yourself. What is given? If a body has constant acceleration, again it is given acceleration is constant, u0 means u0 negative, x0 is positive, and a is again negative. Wow. So let's do first a is constant and negative. That means what? It should be below this line, negative a0. Then if you want to draw velocity versus time graph, if this graph is straight line, velocity versus time should be inclined line. It should be inclined line. So here velocity u is negative, u is negative, u is negative. So here it should be negative u0, and acceleration is also negative. See, both are negative. U is negative, acceleration is negative. That means velocity increases in the negative direction. Always simply, if it is minus a, go in the downward direction. If it is plus a, go in upward direction. That is simple logic we need to understand. So this is what we got it. Wow. Then we need to go with another graph, S versus T graph. S versus T graph. So you need to identify what two things. One is if negative acceleration graph is convex, like that, it is graph is like that. And second is that if it is minus u is given, that means theta should be greater than 90 degree. Theta should be greater than 90 degree. Let's check. If this is the theta, this is the theta we wanted to check. Is it greater than 90 degree? Yes, not less. It is greater than 90 degree. So only this much will work. So it is starting from where x0 is positive, so x is 0. And it is going like that. Wow. Let's erase all the things and let's check. So initial position is given, u is negative, acceleration is negative, both are negative. Fine. The next is graph, AT graph, u is positive, acceleration is negative. So v is linearly decreasing with positive direction. Li is linearly decreasing. The positive direction may not require even. It is by default. Right. So in the ST graph, minus a is convex shape. Minus a represent convex shape and the velocity negative represent theta should be negative greater than 90 degree, slope should be negative. So it is that minus a, we already checked, this is minus a. Then going in downward direction, you compare with the previous one we did. This is with x is equal to 0 if it is, but here it is x is going up. Right. So we already checked this. I think you must have compared this result with your result. You are must be having similar result for you also. One more example. Example number 11. A body is projected vertically upward with initial velocity is given u. U is initial velocity. Take the projection point to be origin. That means starting with x is equal to 0 from the projection point and upward direction as a positive. Draw position versus time graph, velocity versus time graph, acceleration versus time graph. So which graph we should start first? Sir, acceleration graph. We always should start with acceleration graph. From that, conversion is very easy. Let's start. So when a body moves vertically, we know that it is always subjected to gravitational, and for that, when body moves upper direction, acceleration is negative. Acceleration is negative. The body moves in upper direction, acceleration is always negative. We know that, right? We already studied this for the vertical movement of a body. So initial it is having u, it is a positive, and acceleration is having negative. Fine. So now what we need to find out the first. So for that we already have first knowledge that in the case of acceleration versus t graph, acceleration is minus g, acceleration is minus g. So here our solution is like that. Here it is minus g, right? Then what next? AT and VT graph, AT and VT graph. If it is g, it is constant. So for that graph, it is linear. It should be linear for velocity versus time. When you talk about velocity versus time, graph should be linear. Graph should be linear. Graph should be linear. So A is minus c, V is equal to linearly. It is linearly decreasing because V is positive, A is negative. V is positive, A is negative. Therefore, it is decreasing linearly. V is positive, starting with U, and it should decrease linearly like that. Then what next? Then what next? Next is ST graph. ST graph. So we can check minus A minus acceleration is give convex shape, means this shape. This is the shape. Then we need to find velocity. Initial velocity is positive. Initial velocity is positive. So therefore, slope should be positive. Slope should be positive. Let's check positive slope. Which one is positive? Which one is positive? If we just take this theta greater than 90, no, it is negative. If we take opposite side, opposite side, opposite side, opposite side, and this theta, yes, it is less than 90, less than 90. So this slope is positive. This slope is positive. This slope is positive. So we need this side only. We need this side only. We need this side. Wow. It may go away. It may go on also. It may go on. So here, if you grow with ST graph, starting with initial u, initial graph, it is like that. And that if this is the graph, then it should go in this manner only. In this manner only. You will see how it works. How it works. Right. So here, this is negative g, negative g. Then u is starting from this position. U is starting from this position, inclined line. This all the equations we will study in the upcoming chapter. And then maximum u square by 2g. That was not. We just focusing on shape. So this is the shape we are talking about. The shape, it goes maximum and then it goes to downward direction. Right. So it is starting with origin. Starting with origin. So x is equal to 0. X is equal to 0. That was only the difference from our imagination and the actual one. Now, this is example number 12. Now, in the example number 12, a body is dropped from a height h above the ground. So, it is like the condition is given like that. Is a height is given somewhere h and body is dropped. Body is dropped. Let's change the color. Why don't we change the color? Green color. Body is dropped from h. Therefore, it is having in the downward direction negative velocity at initial position. Initial is 0, but it is going downward, so it is negative, and as well as acceleration is also negative. Fine. Take the dropping point to be origin, so we will be considering this as the origin point 0 comma 0. Wow. And upper direction is positive. This is positive and downward is negative. It is by default, we know it. So here first let's draw first graph. Position time graph? No, acceleration in a time graph we should start. What is acceleration? Acceleration is because of gravity only, and that is negative. It is g minus g at below this. Then velocity versus time graph. In the velocity versus time graph, what should be our requirement? What should be our requirement? Velocity versus time. Let's erase this. Let's erase this so you understand better, man. So initial position is u is equal to 0. Then a is negative, a is given negative, x is equal to 0. Fine. So acceleration is negative and v is linearly decreasing. So it is starting from here. Velocity is starting from here. It is linearly decreasing. So line should be like that, linearly decreasing from the 0 point. From the 0 point, velocity, initial velocity was 0, and it is linearly decreasing. How? Then what next? Then ST graph, acceleration is negative, so shape should be convex. Shape should be convex. Then next is, see, initially starting from 0, but it just directly converting into 90, a negative value, and therefore it should be greater than 90. So we should have negative slope. And how can we generate negative slope of this convex shape? So this side we already solved many a time. This side theta is greater than 90 degree. So it gives negative. Let's do. Wow, wow, it is done. So it is, position is to be taken. Position is to be taken from this position, and it should go like that. Wow, this is the solution. So you can see, you can compare with this. The first is minus g, then you can compare. See, this one is not required as of now. We just need shape, and this is it. This is it. Let's go to example number 13. A body is projected vertically upward from a tower. Wow, 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 from a tower. One tower is going. Let's make a tower here. A body is, let's have another color of body, is projected vertically upward. That means it is moving upward direction. Upward is positive, right? And the tower height is given. Tower height is given h. Tower height is given h. With initial velocity. Initial velocity is u is positive. Take the projection of body to be origin. Take the projection of body to be origin and upward direction. Wow. So here, initially u is equal to positive. Acceleration is negative as g is pulling it down in downward direction. So I always, for any body which is moving freely, acceleration is always negative. X0 is h. Fine. Great, great, great. So first graph, let us have first graph. First graph for what? Always go with acceleration versus time. It is much easier for us to do. Negative acceleration, negative acceleration. Let's change the color. It is negative acceleration is equal to minus g. Fine. Then the second one, it should be velocity versus time. Velocity versus time. So initial velocity is given positive. Initial velocity is given positive. So it is u. It is u. See, body is projected vertically upward from a tower height h with initial velocity u. With initial velocity u. So it is initial velocity u is positive. Initial velocity u is positive. Initial velocity u is positive, and g is negative. Means acceleration is negative. Acceleration is negative, right? Acceleration is negative. So what it should go? It should decrease. This should decrease. This should decrease. Velocity is decreasing with time. Velocity is decreasing with time. So at somewhere 0, it becomes 0, and then in the opposite direction it increases. In the opposite direction it increases. Oh, then what next? Then what next? See, acceleration is negative, therefore shape is convex, and we need to check initial. Initial u is positive. So theta should be positive, theta should be positive, theta should be positive. Let's change the color. Theta should be positive, so this slope should be positive. This is the slope. This is the slope. So if we draw this graph, it goes like that. Goes like that. Let's see. Let's compare our graph with this. So here it is minus g. Starting with positive, it is declining as it is. This is the constant. This line is inclined line, and if it is inclined line, this should be either convex or concave. If acceleration is negative, the shape is concave, and if it is positive acceleration, this shape should be convex. And then this angle less than 90 if velocity is positive. And if you see on the opposite side, in the opposite side, here velocity is negative. Velocity is negative. Theta is greater than 90, negative velocity. See here, this is the region. Talking about this is the region where velocity is negative. When this u is 0, the particle travels maximum height. You can also understanding of this also. Let's have example number 14. I think you should pause now this video and you should solve this. That's all. A particle start from x is equal to x0. It start from x is equal to x0. Initial speed is given u 10 meter per second and moves with constant speed. Moves with constant speed 10 meter per second. So we can give this as u1, then u2 or v2 is equal to 10 meter per second for 20 seconds, 20 seconds, and then retarding uniformly come back to rest and say, okay, let's do it. Let's do it. So first is given initial position u is given. Here it is given 10 meter per second, right? At initially x is equal to 0. Initial speed is given directly. It is starting from 10 meter per second object. It is having constant speed. It is having constant speed. So acceleration is 0. Let's draw acceleration versus time graph and as velocity versus time graph. So for the part 1, let us just divide this into part 1. So part 1, acceleration is 0, v is 10 meter per second for 20 seconds. For 20 seconds. So this is part 1 where acceleration is 0, it is velocity is 10 meter per second and it is for 20 seconds. Part 2, see what is mentioned? This is part 2. Then retarding uniformly come to rest in the next 10 seconds. Then come to retarding uniformly come to next 10 seconds. So after 10 seconds, right, initial velocity v was 10 meter per second for the part 2, and it goes means final it is 0, it goes to 0, and it happen in time 10 seconds. So if you wanted to have acceleration, so we know that final velocity minus initial velocity, final minus initiality, v minus u divided by time, that gives 0 minus 10 divided by time is given 10, so become minus 1 meter per second square, minus 1. And for the retardation, we know that retardation, if it is retardation, so it is negative acceleration, and therefore velocity decreases linearly. Therefore, velocity decreases linearly. We know that negative acceleration, positive velocity. That means velocity reduces. We know this rule by heart now. So here, then last is ST graph. Acceleration is negative for the last portion. Therefore, it is a convex shape. Shape is like that, like that, like that. And velocity it was positive. Positive velocity shape should be positive. Shape should be positive. So what should be shape? Shape should be from this side only. This is positive less than 90 degrees. So let's do for the part 1 v is 10 meter per second, acceleration minus 1 meter per second, that already we know it. Let's do first. So for acceleration, see, for the initial time, acceleration was 0 up to 20 seconds. For this region, acceleration is 0. Therefore, it is the line is flat in this. Then for the second region, retarding uniformly comes to rest. That means for the next region, we already have minus 1 meter per second retardation. For the next 10 seconds, so therefore it is minus 10. Therefore it is minus 10. Now here acceleration is 0. That means velocity is constant. Acceleration is 0, velocity is constant. Here acceleration is equal to minus 1. Velocity decreases linearly. So here acceleration is constant. That means velocity is also constant. Velocity is also constant. Then here acceleration negative. So velocity from positive velocity it decreases to 0. It decreases to 0. Then the last graph here velocity is constant. Velocity is constant. That means for this region displacement is linear. Displacement is linear, and here velocity is velocity is decreasing. Velocity is decreasing here in this case. Velocity is decreasing. Velocity is decreasing. So we need to identify. We need to identify angles. We need to identify angles. Right. So first is that negative. So the shape is like that, convex, and velocity is positive. Velocity is positive. So here we need to just have angle theta should be less than 90 degree. So therefore, first region it is straight line up to 20 it is straight line, and then it is having convex with theta positive. Theta positive is less than 90 degree angle. Simple. Example number 15. Conversion of velocity versus time graph to speed versus time graph. Wow. So as we know that magnitude of velocity represent speed, therefore whenever velocity goes negative, take it mirror image about the time axis. So what is we are converting? If there is a velocity graph, so velocity is having negative and positive both the values. But speed is not having negative value. It is having only positive and positive value. See what is velocity? What is velocity? Velocity is equal to displacement divided by time, means shortest distance, and it is direction. But whenever we talk about speed, is a total distance divided by total time. So there is only this difference. There is a difference, and whenever there is a graph like that, see for example, velocity is given like that, but speed cannot be negative. Speed cannot negative. So you just flip this direction. Just flip the direction like mirror image. So it gives a speed graph. It gives a speed graph. Similar here, this velocity cannot be negative when we talk about speed. So you just need to flip this graph. You just need to flip this. So it will be okay with that only. It's okay with this. Let's go further. Now let's read this XT graph. This kind of graph was previously also we have seen this. One graph is representing A line and another is representing B line. So there are different comparison. First comparison, see, body A starts from origin, of course. body starts from origin and at t is equal to 0, right? It start from body A start from origin and body B starts from T1. This is first observation. Second observation, if it measure angle, see both are having theta are having less than 90 degree. This is also less than 90 degree. That means both the velocities are positive. Both the velocities are positive. Then both the velocities are constant. See, there is this graph is constant, this graph is also constant. That means acceleration is 0. That means acceleration should be 0. Or it can have constant also. You can have constant acceleration also. That will work. Then what next? Next is angle of B. If we just compare angle of A compare with angle of B, which angle is bigger? Which angle is bigger? Theta B is bigger. Theta B is bigger. Theta is smaller. That means if angle is bigger, velocity is higher. That means line B shows higher velocity. Line B shows higher velocity compared to line A. Then next comparison is that this T2, at T2, at T2, both are having similar displacement. Both are having similar displacement x1, x1. And last observation, or you can have more observation also. See, B starts from 0. So B travels from 0 to x3 and A travels 0 to x2. That means B travels more. B travels more. So these are the observation. Let's have one more reading from that. It is given like that. A is here, B is here. It is given. So very similar to the previous case. A starts from origin and B starts from x0. A starts from origin, B starts from x0. That is the first observation. Then what is next? See this theta less than 90 degree. Again the theta for A is also less than 90 degree. So both are positive. Both velocities are positive. Then third, acceleration can have constant value also. That is also okay. Theta, this is theta A, this is theta B. Which one is bigger? A is bigger. See, you can even compare also slope. Directly slope you may compare. The slope is a bigger slope, larger velocity. So theta is bigger, velocity of A is bigger. Velocity of A is bigger compared to B. Then next comparison is given at T0. At T0, both are at the same distance x1, and A travels more compared to B. A travels larger compared to B. So we have one more graph. Let's read this graph. Here, A graph, it is given inclined line, linear line, and B is having some kind of non-linear curvature. So how to read this? So first, A and B both are starting from where? Both are starting from its initial position, origin, that is very well known. Then, see, we may compare angle of both. This is VA. For VA, we may compare this VA. So theta A, can we say it is less than 90 degree? Yes, of course, we can. And what about for B? We can take tangent is already there. Theta B, it is also less than 90 degree. So both are having positive velocity. Both are having positive velocity. Then see, velocity of A body. This is velocity of A body is linear. That means acceleration. That means acceleration of body A is constant. Acceleration of body A is constant. Then for VB, it is shape is having concave. We know that this is the shape concave. Therefore, acceleration should be positive. For body B, acceleration is positive. So V is positive, acceleration is positive, so V increases, V increases. Then at t is equal to t1. So here this is the point at t is equal to t1. If we take tangent, tt, so this tangent line is parallel to line A. Both are observing equal theta. That means at t1 position, A and B are having same velocity. Both are having equal velocity. Good. Then next, at t0, both are having same distance x1. So it is not here. We can say t0 fine. So not this position, at this position t2. So it should be at t2. At t2, both are having similar distance travel. We may write its name also. This is the t2. Let's call this x1. Then B travels more. Yes, of course, B is traveling more compared to A. And then this the tricky part is there. For T is less than T1. So up to this position, let's go up to this position. So this is the theta B, and this is theta A. So can I call theta A is greater than theta B? Theta A is greater than theta B. Theta A is greater than theta B. That means velocity of A is higher. Up to this portion, velocity of A is higher. Velocity of A is higher. Here it should be A. And thereafter, if you just compare this angle, so this is make it tangent. This becomes theta B, and this is theta A. So we know that theta B is greater than theta A. So after T1, velocity of B is higher. Velocity of B is greater, right? So T is equal to T2. B overtakes A in terms of displacement. So let's have example number 16. What is mentioned? The position time graph for two children A and B returning from their school O, this is the point O, to their homes P and Q respectively are shown in the figure. Choose the correct and raise in the bracket below. And this is from the NCRT. See, do not forget to read each and every word of NCRT books. After all, your question paper is coming from the NCRT. May not be directly questions, may not be there, but all the logics, all the fundamentals are coming from the book. So do not forget to read your book. So let's start. So first it is given A oblique B lives closer to school than B oblique A. See this distance travel. So we can see here A is traveling P distance, B is traveling Q, and Q is higher. So who is living closer? Who is living closer? A lives closer than B. A lives closer than B. Second is A oblique B starts from the school earlier than B oblique A. So who is starting earlier? A starts early. A starts early. A starts early. A starts early than B. You can see here who starts. A starts early at 0 position. B starts somewhat little late after some time. A oblique B walks faster than B oblique A. See, the slope defines that theta B is greater than theta A. This is theta A. So that means what? B. B walks faster than A. Then A and B reaches home at the same or different time. See, when they reaches, see, if you just compare the time, B reaches at this position. Let's change green color. So B reaches earlier compared to A. So no different time. There should be different time. A B overtakes. If they're in overtaking, yes. See B. It is crossing. B is crossing. B is crossing. B overtakes A. How many times? Only once. Only once. It is once. So yeah, we can compare. A leaves closer. A starts early. Right. Theta B is so B walks faster. Right. Both are at different time and overtakes. B overtakes A on road once. So this is very simple. Do not forget to solve NCRT book. Believe me, it is very important for the JEE and NEET. Let's have one more example. Example number 7. A woman starts from her home at 9 a.m. in the morning. She starts. Walks with speed. Walks with speed. So initial speed is given 5 km per hour on a straight road up to her office. So she starts from her home. Let us just do this is her home, sweet home. And she goes to her office. Let's make excellent office. Somewhere here she go. So initially she walks at 5 km per hour speed and she starts walk at 9:00 and she reaches office right at some time. So here it is given office distance is given 2.5 km. So we can find time. Velocity is equal to distance divided by time. So from that we can find. Then at 5 she starts from 5:00 p.m. She starts her returning journey and she returns home by an auto rickshaw and the speed of auto is 25 km per hour, right? And the from same distance she is traveling and the distance between this is 2.5 kilometers. Fine, it is good. So a woman walks to office first. So velocity is 5 km per hour is given. So we can find S1 distance is 2.5 km is given and starts at 9 a.m. So what time she will take for that? We know that velocity is equal to S T. We can T is equal to S by V. S is given 2.5 km distance travels and she travels at velocity V5. So ultimately from house to office she need 30-minute time. That means she reaches at office at 9:30. She reaches office at 9:30. Good. Then she is staying part 2. She stay office from 9:30 to 5, from 9:30 to 5 and she is at distance 2.5 kilometer. And mathematically she is at distance from 5 because home we are taking as a origin. That is the reason. Then part 3 we can say from the office she starts from 5, she take auto and she start from 5 p.m. Returns home. What is speed? V is 25 taking same distance but here at that time she just need 0.1 hours, that means 6 seconds, 6 not 6 seconds, 6 minutes. So at 5:06 she will be at home. 5:06 she will be at home. Wow, great. So let's draw it. So here this is the x axis, this is time. So see 9 to 9:30, 9 to 9 she starts from the 0. She walks 2.5 kilometer. Then she stay at office. So 2.5 it should be constant for this up to this region. And then she at 5 she pick auto and within 5:06 5 hours and 6 minutes she back to home. So this velocity is linear and this velocity is linear and this velocity is constant. Very easy. See, this is also again from the NCRT. Do not forget to solve all the NCRT book. We have one more example from the NCRT book. A drunk walking in a narrow lane, takes 5 steps forward and 3 steps backward. We know it. This we have seen this in the cinemas. Various movies are having this kind of a forward and backward stop of a drunk person. So followed again by 5 steps and forward and 3 steps backward and so on. Each step 1 meter long and requires 1 second. So every step is 1 meter long and requires 1 second. Wow. Plot XT graph of his motion. Oh, oh, oh. Determine graphically and otherwise how long the drunk takes to fall in a pit 30-meter away. So here, that person who is having drunk, let's do it. Having some bottle on his hand and moving forward 5 meter, right? And then it returns 3 meter. Then from this position forward 5 meter and continues. Wow, great! And for 1 meter step, he need 1 second. Great. So see, this a drunk walking in narrow lane takes 5 steps forward. So we can say S1 for the first step, 5 kilometer travels, not kilometer meter. Yeah, it is not kilometer. A drunk, I'm not drunk. So in T1 5 seconds. So for 1 meter, 1 meter, 1 meter, it is taking 1 second. So 5 meter, he is taking 5 seconds. So total displacement he travel from this position to next position he travel. This position is 5 meter, and total time is 5 seconds. Okay. Then he just return 3 meter. So it should be minus 3. It should be minus 3. It should be minus 3. So T2 is equal to 3. Total displacement 5 minus 3. So 2. So this the total displacement, it is 2. And total time 5 plus 3, 8. Yes, it is 8. Then S3 again he moves here 5 positive. So the previously he was already have 2. 2 plus 5, it is 7. Total time taken 13. Total time taken 13. Then what next? What next? Again he again return 3 meter. So 3 meter minus become 7 minus 3 become 4, and the time taken is 6. Then what next? What next? What next? Again he moves 5 meter, 5 meter, 5 meter. So plus 5, 9. Total time is 21. Again he return 3. So become 9 minus 3, it's 6. 9 minus 3 is 6. Again, going forward, 5, 5, 5, 5. Just add 5 and minus 3, 5 minus 5 plus minus 3, you do this. So once you finish, it is at 13 at step number 9. So it is having 13 distance where he will be in the pit, and he needs time 37 seconds for that. And if you draw a graph x versus t, so you start with a linear velocity from 0 to 5. Then time, you cannot have negative time for that, but movement is there. So it is 3. It is negative direction 3, negative 3. It is moving in negative 3. Then plus 5, minus 3, plus 5, minus 3, plus 5, minus 3, plus 5, and he is in it. Wow. So easy, so easy. From the NCRT book, you will find easy questions, but we know the answer. That's why that looks easy. Otherwise, they are also tricky somewhat. Example number 19, again from the NCRT book. Figure shows the velocity time graph of a body moving in a straight line. A body which is moving in a straight line, which is shown here. Find a distance traveled by a body 20 seconds and the displacement See, distance and displacement both are different terms. We know it very well. Of the body in 20 seconds and the average velocity in the time interval t is equal to 0 to t is equal to 20. Wow. So see, distance, if you wanted to find, I just multiply v with this area under this region t. So this region you just require to have, and that gives us distance or displacement. So let's have first distance travel. Distance travel. So in the case of distance, we do not consider negative direction. So here in this case, area of AOB plus area of BCD. It is triangle 1 r BH 1 by 2. This is 10. Height is 6. Again 1 by 2. Height is 6. Similar area it is there. So total it become 60 meter. So for the distance, negative sign is not required to consider because when we talk about distance, we take total distance. But when there is a question of displacement, we need to have area time graph. Again, we need area, but this area is positive and the another area, this is negative. So it remains sign with this. So distance travel in 20 seconds. Here 1 by 2 and 6, that is okay, positive. But the second graph, it is having negative velocity. So 1 by 2 and therefore it is 0. Therefore, displacement is 0. Here it is not distance, but it should be displacement. Right. So average velocity is equal to x bar x1 by x2 minus x1. So we need last one, the average velocity in the time t 0 to 20 seconds, 0 to 20 seconds, 0 to 20 seconds. So distance, if you see the distance, what? It is 0. Distance is 0, distance is 0, distance 0 divided by time. Time doesn't matter here. It gives 0 as a. Yo, I know you have been waiting for JEE question, and here is the JEE 2019 question. The lucky batch. A particle starts from the origin at t is equal to 0 and moves along the x-axis. The graph of velocity with respect to time is shown in figure. So directly this figure is given. Just do not read the story. What is the position of particle at t is equal to 5 seconds? So it is given here 5 seconds. Velocity is 3 meter per second. Can we find directly? Can we find directly? Four options are given. Yeah, we know that very simple. Distance is area under speed. What is the area? This is the area. 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 Up to this. Up to this. So first for the first portion 1 by 2, it is triangle. So height it is 2 multiplied by 2. 2 to cancel, so it is 2 plus this square plus this is the square, this is the square. So plus 2 multiplied by 2, 4 plus what is this? This region 3 multiplied by 1, it is 3. Wow, 3 multiplied by 3. So solution is 9 meter. 9 meter is the correct answer. This is 2 plus 4 plus 3, 9. This is 9. Correct answer is correct. Wow. Then 21, example number 21. Well, again, JEE 2019 means we have already solved 20 examples before that. I think you should try by yourself. Why not? This is not difficult. What it asks, a particle starts from origin O from the rest and moves with uniform acceleration along the positive x-axis. Identify all the figures that correctly represent the motion. Right, quantitatively, A is acceleration, V is velocity, X is displacement, T is time. It was asked in JEE mains. Option A, option B, A, B, C. Option C, B, C. Option D, A, B, D. Fine. So what is mentioned here? First is uniform acceleration. First, it is given acceleration is uniform. Right? Acceleration is uniform. मतलब constant. Meaning is constant. Positive, negative. It is second derivative. So acceleration graph is given here, and it is giving acceleration is uniform. Acceleration is constant. So yes, graph number A is correct. So where it is, we can find A is given here, here. This C is not given, so it is wrong. And this is option. Okay, we have now three options. Fine. Then let's check velocity versus t graph. If you see that if acceleration is constant, right, and velocity starting from zero, so we know that if this is the straight line, that should be an inclined line with the positive. So here this graph is correct, B is correct, B is correct, B is correct. So only A is given, so this one is not correct. B is given here, this is the correct, and this is the last one is correct. Right. Then let's check C. Okay, fine. So acceleration is positive. So what should be the graph? Graph should be concave. Final graph should be concave. This is concave. No, this is concave. Yes, D is correct. Where is D? D, 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 D. Wow. So answer number D is correct. So here, let's again solve. A is positive, constant. So this graph is correct. Graph 1 is constant and positive, correct. Graph B, graph number 2, V is increasing linearly, positive, correct. Yeah. C, incorrect because the shape is convex. But A is positive, A is positive. Therefore, shape should be concave. And then also we can find angle also. You can play with angle also. Velocity is positive, so theta should be less than 90 degree. And graph 4 starts from 0. Shape should be concave. It is there. And this is the solution. This is it. If you remember the tricks for the concave and convex shape and A positive and negative, you need not to solve everything. You will get answers much quicker. Answer is D, A, B, T. We already identified this answer. Example number 22, the velocity time graph of a stone thrown vertically upward with an initial velocity u is given 30 meter per second. Okay, shown in figure. So here it is initial velocity u is given. Shown in the figure, the velocity in the upward direction is taken as a positive and that in the downward direction as a negative. That is, we know it. We know it. What is the maximum height to which the stone rises? See, we already seen this kind of velocity versus time graph, and this always when there is a velocity is equal to zero. See, when stone is thrown from the ground, upward direction, it reaches to maximum position where momentary velocity becomes zero, v becomes zero, and then it goes to return, increasing velocity. Right. So here, whenever you find this position B is always a maximum. So displacement, you just need to find this displacement, nothing else. Velocity multiplied by time gives displacement. The area under speed time graph gives displacement. So height is 30 and the time is taken 3 seconds divided by 2. So it is 45 meter. 45 meter is the correct answer. I announce that 45 meter is the correct answer. Not it down. Then example number 23. Again, JEE 2017 mains. The body is thrown vertically upward. Great. Body is thrown vertically upward. Which of the following graph correctly representing the velocity versus time? See, let's draw the graph. See, when the body is thrown upward, so acceleration is equal to minus negative. And when we draw A versus T, so we know that graph is gives minus G. If this is the graph where initial velocity is positive, so V is positive acceleration is negative. So what happened? What happened? What happened? What happened? So velocity is positive. Velocity is positive. Say for example, this is initial velocity positive, right? And then acceleration is negative, so it reduces. Straight line reduces. Can you compare B? Wow, answer is B. Answer is B. A is negative constant, U is positive, so V is decreases linearly from the positive. V decreases linearly from the positive, and it keep on decreasing. It keep on decreasing. You cannot have two velocities at the same time. No, you cannot have. So B answer is correct answer. B answer is correct answer. Only logic is required when you talk about JEE questions. Oh, one more questions we got. The time velocity graph of a stone thrown vertically upward with an initial velocity. So let's have one more example. Example number 25. If t is equal to 0, u is equal to 5 meter per second, a is equal to 5 meter per second square, then velocity after. See, you can solve all of the above examples with the use of equations. Yeah, yes, really, you can solve. Why don't you comment your answer? So we know that v is equal to u plus 80. Put the values. V is equal to 55 meter per second. Or you can solve this graphically also. So at t is equal to 0, it is given u is equal to 5 meter per second. Acceleration is given 5 meter per second square. Then velocity t is equal to 10 second. So v is equal to u plus change in the velocity. That means area under this section we just required 5 multiplied by 10. So it becomes 55 meter per second. So easy. So easy. Then example number 26. The speed time graph of a particle moving along a fixed direction shown in the figure. Obtain the distance traversed by the particle between t is equal to 0 to t 10 second, b t is equal to 2 to 6 second. What is the average speed of the particle over the interval a b in b a b a b? Great, great, great. So we just need to have average speed, nothing else, right? So t is equal to 0 to 10 second, and t is equal to 2 to 6 seconds. Good. So change in the displacement is equal to starting from 0 plus area under this region. One of this total height is given 12, and this is 10, 60 meter. Average speed of the particle. Distance we got. We need time. X is equal to v is equal to x by t, and therefore 60 by 10, that gives 6 meter per second. Average speed of particle over interval a to b, it is 6 meter per second. It is 6 meter per second. One more question, example number 27. The displacement time graph of moving particle is shown below. Oh, the instantaneous velocity of the particle is negative at a point. We just need to find the point where instantaneous velocity is negative. All India pre-medical test 1994. Very simple question. See, for the instantaneous velocity, if it is a negative, we just need to find the slope. So what about slope at C? It is positive. Slope at T, it is approximately 0. Slope of E, slope of E, slope of B, slope of E, it is theta is greater than 90 degree. That means it's a negative slope. And the slope of F, it is again theta is less than 90, so it is positive. So only slope at E is negative. Slope at E is negative. So D slope is 0. E slope is negative. We already seen this is the E slope. This is E slope. This theta is greater than 90 degrees, so it is negative. C and F are positive. C and F are positive. We already checked this. C is positive because this theta is less than 90 degree. For F also, this theta is less than 90 degree. So we know this. T slope is 0. So which answer is correct? Answer number D is correct answer. E. We got one more question. Example number 28. Which of the following curve does not represent motion in one dimension? All India pre-medical test 1992. So first one, see velocity increases, velocity decreases, it is okay, no issue at all. In the B, velocity increases non-linearly, that is okay. But see, option number C, velocity at particular time, two velocity is not possible. There are two velocities are not possible at particular time. Therefore, this option is incorrect. D is also okay, no issue with this. Then example number 29. Look at the graph A to D carefully. Ah, yes. And state with reasons which of this cannot possible representation of one dimensional motion of particle. We are studying one dimensional, and this is from your book NCRTE. Wow. So first case, let us see first case. Time is going in the negative direction. Time is going in the opposite direction. And at time t, it is showing distance x, and this is another distance. Oh, wow, is it correct? At time t, two distances are not possible. See, I cannot be here and in America, both the places I am not. It is not possible. So, therefore, A is not possible. B, time t, there are two velocities. We already seen this case. Two velocities at the same time. It is not possible. It is not possible. Then next, you see here, this is the very tricky. If it was a velocity, then it is a correct. But here it is speed. Here it is speed, and speed cannot be negative. Speed is equal to distance, total distance divided by time. Therefore, it is not negative. See, such kind of tricky question will have a speed word in the question, and there is a great chance to get mistake. Do not make mistake. Then the last, total path. Total path cannot have in the negative direction. It is always summation. Total path is a total distance travel. You cannot travel negative. If you travel negative in this total path, you have to add. You have to add. So this is not. And again, last C and D are having higher chances to get some mistakes. Do not make mistakes. Then example number 13, velocity time graph. Figure shows that x plot of one dimensional motion of a particle. Is it correct to say from the graph that the particle moves in a straight line for t is less than 0? We are talking about t less than 0 and on a parabolic path for t greater than 0 if not suggest the suitable physical context for this graph. NCRT. Do not forget to solve all the NCRT books, all and unsolved. Read each and every word of NCRT books. So graph it is given. See, it is incorrect to say. It is incorrect to say that. See, it is given like that t at negative t, negative t, negative t. It is not having, or you can say object at rest, and then it moves on the exponential part non-linear. See, this statement is not possible because of only one time direction is given. There is no data is given for the x direction. Therefore, this is not possible for that. If we suggest that, so time is less than 0, so here object is at rest because x is 0, object is rest. And then after if there is an increase, so we just need to find the slope. Theta is less than 90 degree, velocity increases. Velocity is positive, and the shape it makes this kind of shape concave. So acceleration is also positive, and velocity positive, acceleration positive, both are positive. Velocity increases. So we have one more example from NCRT book. Suggest a suitable physical situation for each of the following graphs. So graph number one, it is having t somewhere here. T is less than zero. Fine. Let's see from graph number A. So initially, when we are talking about this, yeah, x is zero. It is raised. Wow. Then for A, let's check velocity. Let's check velocity. So for this is less than 90 degrees. So velocity is positive. So velocity increases, velocity increases, velocity increases. Then if we go with this graph, this theta is greater than 90 degree. So velocity decreases. If it crosses here, so it becomes zero momentary. And then in the negative direction, it is going in the negative direction, increases. How? Then then it continues negative direction, it continues. Fine. So this is A is very simple. Now B. So velocity starts from V, graph V. Velocity is starting from V and linearly it is decreasing. So similar of the here line B, if you see this B similar to the line B, that means for this line it is like that, having a similar kind of slope but somewhat more steeper. So it is having this angle, it is this initially, if you see this initially, so it is having negative velocity, and then it is also having, it is not negative velocity, it is positive velocity. See here, this is above V, that means it is positive velocity is going towards negative velocity. Fine, it is having a straight line, it is having a straight line. So from positive velocity becomes zero, and then negative positive velocity, then zero, then negative. Then again magnitude reduces, positive velocity, zero, negative, and continuously magnitude reduces, right? So it is simply an example of a ball falling freely from the height. If you just, right, ball is fall freely and it strike on the ground, then it bounces back up to some height, then it falls, again bounces back, then it falls like that. It is just a ball rebound multiple times, and that is the shown in this. And the graph number C, we can see initially it is acceleration is zero. Initially acceleration is equal to zero, and then suddenly at sudden this point, acceleration suddenly increases like a pulse increases, become maximum, and then it goes to zero. So it is then suddenly what acceleration increases, then very small, and then becomes zero. Example is like that. Batsman hitting a ball, so velocity, maybe fast bowlers is throwing or a bowling, we can say rather, it at some speed 150 kilometer per hour. Oh wow, one top speed, and then ball hits by a batsman, and that suddenly it increases to 500 kilometer per hour speed. Oh wow, what a capacity! And then it return to its original one, and wow. Another one is that in case of football is traveling horizontally when hit ball or gets kicked by a player. So if it is kicked by a player, so player gives its energy and suddenly there is an increase. So let's have example number 32. Figure gives xt plot of a particle executing one dimensional simple harmonic motion. So we will study simple harmonic motion in the chapter number 14. Fine. Give the sign of position, velocity, and acceleration variables of the time t is equal to zero point 0.3 somewhere here. Yes, it is somewhere here 0.3, 1.2, here it is 1.2, and minus 1.2, somewhere here it is minus 1.2. This is from the NCRT. Let's just check. So at point 2, this is point 3, sorry. If we take this, so theta is greater than 90, and point 3 is here. X position is below this line, therefore x is negative. What about velocity? Velocity is also negative because theta is greater than 90 degree. So velocity is also negative, and the shape, it is like that, con concave. So acceleration is positive. So acceleration is positive. Now next is point 1.2, x is positive, directly visible. Then let's take slope, tangent. Theta is less than 90 degree. Theta is less than 90. So velocity should be positive. Velocity should be positive, and the acceleration for that concave shape, acceleration is negative. Right? This convex shape, acceleration is negative. And at negative, let's remove everything. At negative 1.2, somewhere here minus 1.2. X is negative, it is visible directly. X is below this axis, so it is negative. What about velocity? Let's take here. This is the theta less than 90, so velocity is positive. What about acceleration? It is acceleration concave. That means acceleration is positive. So here we have one more example. Example number 33. Oh, how many examples we have? We have plenty of examples. Figure gives the xt plot of a particle in one dimension motion. Three different equal intervals. So time is given equal, in which interval is the average speed greatest, and in which it is the least. So maximum and minimum we need to find out. That's the solution. See the slope we need to find. We need to just find slope. This is the slope theta for 1 and 2, and this is the slope if you see here, right? So if you see the slope theta 3, it is having theta is having greater than 90, so it is negative. It is negative, right? It is negative, and it is also having maximum. It is also having maximum. Slope is maximum, but in negative direction. Fine. Then shape is concave, right? Shape is concave, so acceleration is positive, hence velocity decreases. That may not require even. Fine. So shape of the interval 1, here, if you see the slope of the interval 1, it is having minimum slope if we compare with others. So this is theta, right? So it is having minimum speed. This is having minimum speed, and this slope is maximum. Therefore, it is having maximum speed. V max and V min. Then slope of interval number 2 changes from positive to negative. If it is asked, then you can say positive to negative. So velocity changes from positive to negative. You may check out this. So yeah, it was from NCRT questions, and you may have this. The second comment is additional. This second is additional for your knowledge, but it was only asked that average velocity, and this all we have. So here we have example number 34. So what it means? Figure gives a speed time graph. So this is the figure talking about. This is the story. The three equal intervals of time are shown. In the first, it is important here. In which interval is the average acceleration? See, this is the graph, speed versus time, right? So do not just misjudge. This is not x versus time, but it is speed velocity versus time, right? So slope gives acceleration. In which interval is the average acceleration greatest in magnitude? For acceleration, we just need to have slope. So slope of first, it is like that. Slope of second one, yeah, it looks much bigger compared to one, and slope C like flat. like flat. So yeah, of course, for the answer, the first one, slope of 2 is maximum, therefore it is having maximum acceleration. It is having maximum acceleration. So first answer is done. First is done. This is done. Now is in which interval is the average speed greatest? See, directly this graph is given for the speed. Now you need not to find the slope, right? It is directly given the graph. So here see, highest it is at point D, speed of the particle maximum at position D, and this is for the 3. Yeah, it is very easy. Then choose the positive direction as the constant direction of motion. Give the sign of velocity and acceleration in the 3 interval. Wow, this is question I love. So here velocity is positive. Velocity is positive. So if we take for this one, theta is less than 90. So it is V is positive. Yes, this is positive. Then here, if you just see this, so what happened? Theta is greater than 90. So here for this negative velocity, and for this it is flat, flat, flat. It is flat. Right? Then positive acceleration in the interval of 1, right? As its slope is positive. If slope is positive, acceleration is positive, that we can get it very easily. For negative, if slope is negative, acceleration definitely it is going to be negative acceleration. Here it is positive. See, you can also identify with this the velocity is increasing. Yeah, velocity, all velocities are positive. All the velocities are positive. How can we say velocities are negative for any of this statement? Right. So this was mistake. See, this is positive velocity. So all for all velocity is positive. For this acceleration is positive. For this acceleration is negative, and this is for the acceleration you can say 0. Fine for the momentary. Right. So slope, and the last one is that where are the accelerations at the point A, B, C, D? A, B, C, D. See, all the points are having flat position, flat portion, flat portion. This is 0, this is 0, this is 0, this is 0. Slopes are 0, acceleration is 0. For that, slopes are 0, acceleration. So now we arrive at example number 35. Wow. JEE 2015 mains. And what did it say? Oh, difficult question. Two stones are thrown up simultaneously from the edge of cliff. Maybe stone is thrown vertically, right, from the edge of cliff. What is that is thrown? U is equal to 10 meter per second, and second stone is thrown at 40 meter per second. U is equal to 40 meter per second, respectively. Which of the following graph best represent the time variation of relative position of the second stone with respect to first? That means it is showing distance travel at time t y2 minus y1 as a y-axis and x-axis at t. Oh, difficult. Assume stone do not rebound, that is fine. And g is 10 meter per second. Wow, g is 10 meter per second square. JEE 2015 main the question was asked. Oh, let's solve it. So acceleration is given negative, g constant, u is positive. Initially, stones are thrown at constant velocity, both are positive. So v decreases linearly, x in the convex, that is fine. V velocity decreases, and x become convex because here Acceleration is negative, so this shape is convex. This shape should be convex, right? Now, here we know that distance travel is equal to s is equal to ut plus 1 of at square. So for s1, u is s1, distance of this tower, height of this tower is given. This tower is given s1, distance is given. Then a stone is thrown like that vertically upward. So u is given, u is given 10. T1 we don't know how much time it will require, and here acceleration become minus g. So S1 is minus 240. Direction we have to consider for the entire journey, for the full journey that we already studied previously also. And 1 half A is equal to minus 10t. If we solve this equation, we will be having T1 is equal to 8 second. T1 is equal to 8 second. Similarly, another stone is thrown simultaneously at U is equal to 40 meter per second from the similar height. So minus 240 is equal to 40 T2 plus 1 of minus 10, and we can get T2 is equal to 12 seconds. See, ultimately we know that T1 is less than, smaller than T2. That we know very well. See, up to T1 travel means for the first 8 seconds, both are stone on air. Both the stones are on air. Right, both the stones are on air. That means if we take the difference, see we got here s is equal to ut plus 1 of at square. If we take distance s2 prime minus s1 for the first 8 second, if we take distance for that, for the first 8 second, so we can put s2 is equal to value is equal to u is 10 t1 minus 40 t1, or you can take 40 minus 10 is equal to 30 is equal to 30 t1. If you see here, this graph displacement difference is directly proportional to p. So that graph should have linear position, linear movement. The first movement should be linear. Wow. Then after 8 seconds, means 8 to 12 seconds, the first turn is not having any movement. So first turn becomes zero, stay movement becomes zero, and only it is having stone number 2. Only it is having movement of stone number 2, and here when it is having G is negative, it is having convex shape, So this is, the shape is like convex. And velocity is also negative because it is a returning journey. Velocity is negative when the object moves in downward direction. So for negative, we need negative slope. Of this. So this is negative slope. That means we require only this one side. We need this one side. So see, this calculation is just to show you how it works. Simply, you just need to do this T1 is always less than T2. Fine. So at or up to T1, both stones are on air. So at that time, you can have S2 minus S1 is equal to 40 T1 minus 40 T2, because acceleration portion that will be cancelled. It is equal for both, and this will be cancelled. Right. So here up to this portion, it is having linear. So yes, it is linear. It is having linear. It is having linear. It is having linear. It is having, all are having same equation. So this calculation you are not required. So what we required? We just required to have, once the first stone is on the ground, second stone is still moving on air. Up to some distance it has to travel, and it is having minus g, and therefore it possesses this kind of convex shape with a negative direction. So this one is correct. So therefore B is correct. Therefore B is the correct. So now we have Example number 36, JEE 2005. The given graph shows the variation of velocity with displacement. Oh, see, up to now we already have graph A versus T, acceleration versus T. But this graph is velocity versus X and acceleration versus X. Oh, this is something different. So what is mentioned? Which one of the graph given below correctly represents the variation of acceleration with displacement? JEE 2005. The question was asked. So here, see, graph is given velocity versus displacement. Velocity versus displacement. The relation is given linear. Great. So from that, we know that y is equal to mx plus c. Y is equal to mx plus c. Line equation m. If you wanted to have m, so can we say this y is equal to v, x is x, fine, x is x, fine, m is equal to tan theta, x is equal to tan theta. So theta, this is the theta, so it is negative. Tan theta, it is giving negative. This side, perpendicular side, v0 divided by nearer side, x0. And c interceptor, y interceptor when x is equal to 0, x is equal to 0 when x is equal to 0. This is v0. Wow. So we can put here v is equal to minus v0 x0 x plus v0. We know that acceleration is equal to dv by dt. So dv by dx is equal to dx by dt. See, this kind of examples we solved before also. And dx by dt is equal to v. So acceleration is equal to v dv by dx. dv by dx. So we have value of v. Do we have value of v? Yes, we have value of v. Put this here. Do we have value of dv by dx? We can differentiate this. Why not? We can differentiate it. So minus v square by v0. It just remains this one portion. Put this here. Right. Let's simplify this equation. So can we say minus minus plus v square by x0 power 2 x minus v square by x0. Can we take this equation like y is equal to this is m, x minus is plus. So here m is positive, m is positive, m is positive, m is positive, slope is positive. Is it positive? Yes. It is not there because it is not representing slopes. Here let's check this slope, this slope, this slope. Theta is greater than 90. Wrong. This is greater than 90. Wrong. Oh, only one option. A option is that. This is correct. And also you can find this is minus, interceptor is minus, so it is also here negative side. Right. So answer A is correct. Oh, wow, what a question. Difficult. Oh, one more question. The area under velocity time graph between any two instants t is equal to t1 and t is equal to t2 gives the distance covered in the time dt t2 minus t1. Wow. So option A is given only if the particle moves with uniform velocity. So it is given like that in the velocity v time graph. Whatever area under this region gives displacement, right? That we know, or distance covered. The condition is given only particle moves uniform velocity. If uniform velocity it is there, so v is uniform, then only it is applicable. Second is that uniform acceleration. If acceleration is uniform, then it is applicable. Only if the particle moves with an acceleration increasing at uniform rate, or in all cases irrespective of whether the motion is one of the uniform velocity or uniform acceleration. See, it is simple, yeah. See, under the area velocity gives always give distance covered, irrespective of any condition. It is just a summation of all the velocity multiplied by time. So it is true, irrespective of whether the body has uniform velocity or non-uniform velocity, whatever condition. Area under the acceleration, no, sorry, velocity time curve always gives its distance or displacement. Oh, one more question. 38. The variation in the speed of a car during 2 hours of journey is shown in the figure. Yeah, but this one is figure. The magnitude of the maximum acceleration. See, for the maximum magnitude acceleration, you just need to find which theta is bigger, which slope is the, you can say, the tallest, the steepest. For the AB, it is 0. Which theta is the biggest? Which theta is the biggest? You see here, this BC line is having a biggest theta, right? Answer is BC. Answer is BC. Simple. One more example. So in the graph is shown in the figure magnitude of the acceleration. So graph is VT and the slope gives acceleration position. Which one is the maximum? You just find the slope. Slope. Which slope is maximum? B slope. It is having this one. If you consider the C slope, yeah, C is maximum. 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 If you see, B is having small positive, D is having small negatives. Slope C is largest. Small C is largest. Therefore, answer C. C is the correct answer. C is the correct answer. Example number 40. Oh, we reach up to 40. All India pre medical test. A particle shows distance time curve as given in the figure. The maximum instantaneous velocity of the particle. Again, we need to find the slope. We just need to find the slope. Which slope is the biggest? Which slope is the biggest? You can see here this one is the largest slope, and therefore C is giving the maximum. One more example, we have JEE 2018. Ooh, all the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. JEE 2018, it is asked. Wow. Let's solve it first. Let's solve it first. So first, if we talk about the first, it is giving velocity versus time. So initially, velocity is positive, right? Then momentary, it becomes 0, and then it becomes negative. It's okay. It happens. There is nothing wrong. You can just take an example of ball. Ball is thrown vertically. Velocity is positive and reduces. At top, it becomes 0. Then it goes down and negative velocity increases. Negative velocity increases. Fine. So first one, no issue at all. Right. For the first, no issue. For the second, it is the graph is velocity versus position. So we know that velocity is starting with positive, and it is starting with 0 position. Fine. So here, if you see, this is the h. If you take h is equal to 0, and here h is maximum. So in the position from that with velocity start with 0 position, and that increase velocity decreases, position increases. So here the similar case velocity decreases, height increases, and there velocity becomes 0, position is maximum. Then velocity is 0, velocity increases in negative direction, and then it's going down, position h is 0. So h is 0. Fine. H is 0. Yes. So B is correct, A is also correct. There is no issue with A and B. Then let's check graph number C. So it is having dual motion, we can see here. Half shape, it is like that. It is having convex. It is not convex, it is concave. It is concave. Yes. So that means if there is a concave shape, simply acceleration should be positive. Acceleration should be positive. We have taken examples for the case 1 and 2 in which it is like a free movement of body on under gravity. So g is should be acceleration should be minus g, and therefore first half the graph is concave but it should be convex. So therefore this is the wrong. This drawing is wrong. This drawing is wrong. This drawing is wrong. Right. So graph C is incorrect. Graph 4, position versus time graph. The distance, of course, it initially it's starting from a zero with time, going on the top position with the time reaches to top position at zero, and then it goes back to zero. And after some time, yeah, it is correct. It is correct. It is correct. So only C is wrong. Only C is wrong. And the correct graph it should be here. See here. The correct graph is shown here. Initial shape should be like that. Initial shape should be like that. It should be a convex. Initial shape should be convex. Then it can go with concave shape. That is fine. Or it is never a concave shape. So we have example number 42. A ball is dropped vertically from height d above the ground. So see, suppose a ball it is taken here. It is dropped vertically in the downward direction from height d. It hits the ground and bounce up vertically. It hits the ground. It hits the ground and bounce up vertically up to what portion d by 2 height. Right, neglecting subsequent motion of air resistance. Its velocity v varies with height. So again, it is given v with x distance or h. Right, the total is h, or you can say d. Fine. JEE 2000. Great. So if we consider this situation, you can solve this by using this equation also. You can solve this equation also. Why it should be solved by this equation? See, you can also take directly acceleration is equal to minus g, so that your curvature should be convex. Curvature should be convex. Wow. But it is applicable when you draw graph velocity versus t. May not be applicable here. Let's see. So first is vertically drop the ball, and we know that v square minus u square is equal to 2as, right? And we know that initial velocity is 0, so v square is equal to 2s, and s is directly proportional to v. That means it gives some concave or convex shape. We can identify from that, right? So it is a parabolic shape. Curvature is not, it's not a straight line. We can identify it is not a straight line. Then for the stage one, when the ball drops from the top, initially u is equal to 0, acceleration is equal to minus g, and it is having negative velocity after some time. Right. So velocity decreases. So velocity simply you can say decreases, or you can say increases in the negative direction, or vertically downward, right? So in the first case, velocity starts from the zero. If you check this velocity, is it starting from zero? Yes, it is starting from zero and it is decreasing. Fine. So this one can be okay. Velocity is not starting from zero, so this one is wrong. The third one is, see, the shape should be either concave or convex. So C is also incorrect. D we can see velocity is not starting from zero. So this one is also incorrect. Only A is having option as a correct. But let's see again. So distance decreases. So distance is maximum. It is here. D is equal to here maximum, and when it moves downward direction, so distance becomes zero. Distance decreases. So we can see here for that distance, is it decreasing? Yeah, distance is starting from maximum and it is decreasing along with this. Yes, so this one is correct. In this distance, it is not decreasing. Distance is decreasing, yes. Distance is not decreasing, right? Similar, similar. Stage number two, ball bounces up vertically to height d by 2. U is equal to positive velocity, U is not equal to 0, G is negative. So what we can do, vertically decreases, direction is positive when the ball bounces up, U is positive and G is negative. So velocity decreases from the maximum. So here it is d by t we can take, or not d by t, sorry, v by, it is having some lesser velocity, right, and decreases with height, increases, decreases with height, increases, yes. So this one is the correct, this one is the correct. So distance increases from 0 to 2, right? So from moving 0, it increases to d by 2. It is increasing somewhat half d by 2. So therefore 1 is correct. Answer 1 is correct. You may also solve once again, right? With a calm mind. You can get this answer within this step. As I mentioned earlier, this step, from this step, you can get the answer. So one is, it should be a parabolic shape, or simply you can say concave or convex. So therefore this answer is incorrect. Second is that v starting from 0. So velocity should start from 0 for the first interval. So you can say yes, starting from 0. For this, it is not starting any of, not starting from 0. Or here it is also not starting from 0. So answer A is correct. Directly you can solve this question easily. Again, understanding is given here like that. See here, from 1 to d, V increases. So V increases in the downward direction, right? Along with H decreases. Side 2, velocity changes its direction and magnitude. 2 to 3 decreases upward. So velocity decreases moving upward. So H increases. This is not so simple. It is somewhat difficult to understand, as we are habited to work with V to T diagram, but not with the other diagram. So you have to change this habit also. We have one more example, example number 43, and the similar question was asked in JEE 2019, and we already solved this kind of question while solving motion under 1D. So what is asked? The velocity v of a body moving along the positive x direction varies with displacement x from the origin. So equation is given, v is equal to k root x, where k is constant. See here, equation is given, k v is equal to k root x, and we need to find here slopes from x versus t graph. So we need to convert this equation either in terms of vt or in terms of x t, right? Otherwise you cannot solve it directly. It is not possible to solve it directly. So let's see. So v is equal to k root x is equal to v, we can just take square on both the sides. So v square is equal to k square x. Then dv square, we can differentiate, we are differentiating this term. Dv square by dt is equal to k is constant, you can take outside, k square dx. So it become 2v, dv by dt is equal to k square v, and dx by dt become v, right? So now we need to have dv on one side and the opposite side other thing. dv is equal to k square by 2 dt. We can take integration on both the side. dv, here it is not v. So 0 to v dv k square by 2, 0 to. So it becomes just v is equal to k square by 2 t. So we got here velocity as a positive. From that we can identify velocity as positive, and acceleration is also positive, and acceleration is also positive. So for that positive acceleration, what should be shape? It should be having a concave shape. It should have a concave shape. That means concave shape. And velocity is positive. That means theta should be less than 90 degree. Slope should be positive. So when we are talking about slope, for this slope, if we take this, so this theta is less than 90 degrees, so this slope will work. Just compare, this is not the one, this is not the one, x versus t, because here velocity is directly proportional to t. That means x, it is not, it should have curvature, it should have proportional to somewhat, x should have proportional or t square or something like that. So first two options are incorrect, first two options are incorrect, second and c and d is possible. So the c and d, this is the correct, we already checked. So this is the shape, yes, and this is theta less than 90 degree, yes, this c is answer is correct. Right, so you may further also you may go with this, or you may continue v is equal to dx by dt k square by 2t. Again, you may do differentiation for the same, and you can get x is equal to k. So x is proportional to t square. We already identified from this region also the similar case from the graphical representation. No further. So x is proportional to t square. Hence, option C is correct. Hence, option C is correct. Great. So up to this much is sufficient. You can go with this. But yeah, question was really difficult. But we have to practice for that. Oh, we are at the last question, example number 44, and some statements. Statement 1, a body moving in a straight line may have non zero acceleration at an instant when its speed is 0. Statement number 2, if a body is thrown vertically upward, its speed at the instant when it reaches the highest point is 0, but its acceleration is 9.8 meter per second. Statement 1 is true, statement 2 is true, and statement 2 is the correct explanation for statement number 1. Is it correct? Statement number 1 says that a body moving in a straight line may have non-zero acceleration. May have non-zero acceleration means acceleration is not 0, but velocity is 0. And we know that, right, when a body is thrown vertically, at when it reaches to top, velocity is 0, but acceleration is equal to minus 9.8. Minus 9.8. So it is given here, if a body is thrown vertically upward, its speed at the instant when it reaches to highest point it is 0, but acceleration is 9.8. So statement 1 is true. Fine. Statement 1 is true. Acceleration can be non-zero and velocity can be 0. But statement number 2, right, is also true. Both are true. Fine, both are true. So statement number 2 is correct explanation for statement number 1. So I do not agree with this. Here, statement number is true, but statement number 2 is not correct explanation for statement number 1. How? How? See, acceleration, it shows a rate of change of velocity. Acceleration is show rate of change of velocity, delta v divided by delta t. It is showing rate of velocity. That means what? See, at this position, velocity may be 0, but just before and after, velocity was not 0. So acceleration is just rate of change of velocity. Not at this point. It is changing, it is measuring nearby places, and therefore acceleration can be 0. Right. So here at the top position, velocity can be 0, but acceleration is a change of velocity delta v by delta t. So we are comparing with nearby position, not the same position. Therefore, see, statement 1 is true, statement 2 is true, but it is not a correct justification. Correct justification is delta v by delta t should be acceleration, and therefore at v is equal to 0, but at nearer point delta t, v is not equal to 0. Therefore, it gives acceleration. So thank you for watching Physics Doctor. Please subscribe to Physics Doctor.